Good morning, everyone, here in Singapore, and a warm welcome to our global community joining us from around the world. I'm Mahendran, Reddy, Head of Ecosystem at the National Additive Manufacturing Innovation Cluster. It gives me great pleasure today to welcome you to the NAMIC Global Additive Manufacturing Summit, a part of the Industrial Transformation Asia-Pacific, a Hannover Messe event. This will be our first virtual edition of our flagship AM Summit series since its inception in 2017. Held in conjunction with the Industrial Transformation Asia-Pacific, which is a Hannover Messe event, ITAB as it's better known, it will harness on ITAB's leading digital platform to connect with a global audience as one of the anchor events for Asia's leading Industry 4.0 event. This year has been unprecedented with COVID-19 global pandemic that has completely transformed the way we are communicating, connecting, and doing business. We are delighted to bring to you over the next 2 days insights from global thought leaders who will share their expert knowledge and know-hows on AM, as well as to inspire new ideas and inspirations to our global audience. The summit will feature 4 half-day segments. Today, we will focus on sustainability and emerging applications, featuring topics on how additive manufacturing will enable a sustainable future for humanity and power emerging applications on areas in smart urban solutions, space industry, and cellular agriculture, as well as experts panel discussions helmed by subject matter experts where you have the chance to pose burning questions. So much is in store, and I'm really excited to get the day started. Without further ado, it is now my pleasure to invite Dr. Ho Chaw Sing, Managing Director of NAMIC, with his welcome address. Welcome, Dr. Ho Chaw Sing. This is indeed a new environment for us. We are in a virtual world and addressing all our global audience, and they're all dying to listen to you with your welcome address. Over to you, Chaw Sing.
Thank you, Mahendran. Mrs. Ling, Minister of State, Ministry of Culture, Community and Youth, and Ministry of Trade and Industry, Chairperson of Mayor's Committee and Mayor Southwest District. Distinguished speakers, guests, friends and colleagues, ladies and gentlemen, good morning. On behalf of the organizing committee, it is with tremendous pleasure that I welcome all of you to the NAMIC Global AM Summit, held in conjunction with the 3rd Industrial Transformation Asia-Pacific, a Hannover Messe event 2020. This installment, our 9th user-focused AM forum since our inaugural event in 2017, focuses on innovation for sustainability, as well as some of the most intriguing emerging applications of additive manufacturing. We're very honored and pleased to have with us today several thought leaders from our global and Singapore AM community. All of them have one common trait, and that is they dare to dream and are pioneering innovative use cases in their respective domains with AM adoption, be it in industrial engineering, urban solutions, alternative proteins, or space technology, ranging from startups, public listed companies, to nonprofit organizations. Unlike previous ITAB installments, due to COVID-19, we're unable to feature any startup this year at our Startup Pavilion. We hope to be in a position to do this again at the next ITAB installment end of next year. One of the US-based startups showcased last year at Singapore AM Week and ITAB 2019 Startup Pavilion, Molyworks in the US, has since established a base in Singapore and will be kicking off the sustainability session today in a while. With rapid industrialization and urbanization, we're facing unprecedented planetary scale challenges in the last few years. Climate change is no longer a scientific debate. Extreme weather conditions such as droughts, massive forest fires, and floods are sadly now an annual occurrence. On the positive side, governments around the world are increasingly responding by laying down policies and goals towards reducing carbon emissions. China, one of the largest industrialized nations in the world, has taken the lead by announcing that they aim to be carbon neutral by 2060, which bodes well for other countries to follow suit. The world ahead is challenging, where geopolitical tensions, coupled with changes to deep-set habits caused by the pandemic, has inevitably accelerated changes to the way we make, consume, recycle, and upcycle. All of us, businesses and individuals, will need to reinvent and evolve to stay relevant and in business. In addition, businesses, whether it's in the aviation sector, education, supply chains, and deep tech, would become more interlinked and connected through the adoption of new technologies, and this is something that will continue to gain momentum. 3D printing has played a very important role in enabling new paradigms in rapid medical supplies product development to address the disruptions in global supply chains, as well as fast deployment enabled by on-demand, high-impact manufacturing. The COVID-19 pandemic has also shown that we are living in a global village with complex interdependencies among nations. Sustainability in development and manufacturing are no longer catchphrases, but are increasingly important. Our vision for the future is a net carbon neutral world with biomimicry-inspired, topology-optimized products and solutions enabled by on-demand distributed manufacturing with recycled and sustainably sourced materials. We aspire that our future engineers will adopt design thinking with design for AM, leading to outcomes and solutions that are innovative and human-centric, leading to better and more sustainable products and services. To the many users and adopters of AM or 3D printing, the ability to harness recycled materials as feedstock for AM, optimize product designs by going through an iterative simulation and redesign process, allowing it to be manufactured in a way that is more sustainable with minimal material wastage has become paramount. On-demand manufacturing and other benefits such as lightweighting, AM combined with digital technologies has the potential to transform our future for the better, resulting in more efficient supply chains, lowering carbon footprints, and integrating some recycled materials into the manufacturing supply chain. One of the underlying motivations for us in curating these conferences every year, beyond providing a platform for ideas and best practices sharing, is to empower current and next generation of engineers with the tools and technology of which 3D printing is central, so as to solve increasingly complex problems in the world. On this note, I'd like to take the opportunity to thank our speakers who have taken valuable time out of their busy schedule to prepare and speak at this event. These are some of our leading thought leaders in additive manufacturing. We are at the start of this journey, and we'll need all of you listening in today to help us lead the way. On a final note, I want to thank the wonderful team that is behind this event. The entire NAMIC team, together with our partners from Advocate Singapore, SingX, and Deutsche Messe, have worked tirelessly since June to put all of this together. I hope all of you here today will benefit from the content we have put together for you. I wish you all a very fruitful and productive conference ahead. Please enjoy the show. Thank you very much.
Thanks, Chaw. Thank you for that welcome address. And I think all of us are here really excited to get the day started. And all our speakers and our team has put together a wonderful show. And we would also like to welcome at this time and to introduce our esteemed guest of honor. We are deeply honored today to have Ms. Low Yen Ling, Minister of State, Ministry of Trade and Industry, Ministry of Culture, Community and Youth, Chairperson of Mayors Committee and Mayors Southwest District, to grace our summit as the guest of honor. It's my pleasure now to invite MOS Low to address us. Minister, please.
Dr. Alex Lin, CEO, Intuitive. Dr. Ho Chow Sing, Managing Director, National Additive Manufacturing Innovation Cluster, NAMIC. Distinguished guests, ladies and gentlemen, a very good morning to all of you. I'm very pleased to join you here at the NAMIC Global Additive Manufacturing Summit 2020. This 9th edition of the virtual NAMIC Summit brings together key thought leaders, startups, and industry professionals in the midst of a global crisis. The COVID-19 pandemic is undoubtedly one of the biggest healthcare crises of our generation. When the pandemic first broke out, demand for personal protective equipment and test kits soared. Some countries imposed export bans to cater to domestic needs, leading to supply chain disruptions across the globe. To mitigate the supply chain disruptions, the additive manufacturing community stepped up by ramping up the production of essential medical supplies for Singapore. NAMIC led a task force comprising experts from NUS, NUH and several local enterprises to design and produce Singapore's own 3D printed nasopharyngeal swabs in less than 7 weeks. To date, the task force has printed more than 5 million swabs. I thank NAMIC and the task force members for your invaluable contributions to our nation's efforts in combating COVID-19. The pandemic has demonstrated the growing importance of additive manufacturing in enabling innovation in many up-and-coming industries such as medical technology and marine and offshore. As one of the few countries in the world with a coordinated strategy to leverage additive manufacturing to transform emerging industries, Singapore is in a good position to harness the benefits of 3D printing to change, disrupt, and innovate manufacturing processes. To strengthen Singapore's status as an innovation hub for additive manufacturing, the government has committed resources to building our talent pipeline. For example, through the Research, Innovation and Enterprise 2020 Plan, $3.2 billion was allocated to R&D for advanced manufacturing and engineering. In addition, to ensure that we have a complementary skilled workforce, the Singapore government is also investing in our talent pipeline by training more than 600 engineers in additive manufacturing design and process capabilities. Additive manufacturing technology centers based in our institutes of higher learning, such as the NUS Center for Additive Manufacturing and the SUTD Digital Manufacturing and Design Center, are launch pads for homegrown additive manufacturing innovation. I'm very encouraged by NAMIC's efforts to accelerate the adoption of 3D printing technology and addressing challenges companies face in implementing this technology. Since its inception, NAMIC has successfully raised more than $50 million in private-public funding to support over 200 additive manufacturing projects ranging from industry verticals such as healthcare, medical, construction and marine offshore. In partnership with MPA and the Singapore Shipping Association, NAMIC has also recently announced Phase 2 of the Joint Industry Program, JIP. Under Phase 2, the JIP will apply additive manufacturing technology in the marine industry by bringing together key industry players across the value chain to showcase the potential of 3D printing technology for maritime parts. It is heartening to know that the number of players in Singapore's additive manufacturing ecosystem has continued to grow amidst COVID-19. Just last month, Siemens officially opened its Additive Manufacturing Transformation Center, AMTC, providing a one-stop advanced manufacturing ecosystem that facilitates local companies' transition into 3D printing and Industry 4.0. Under the SG United Mid-Career Pathways program, Siemens will also be organizing a 6-month additive manufacturing learning program at the AMTC, which will provide Singapore trainees with relevant skill sets to support the current wave of industrial companies undergoing digital transformation. As we continue to reopen our economy, we must harness the potential of additive manufacturing and strengthen Singapore's reputation as an innovation hub for 3D printing. To place Singapore at the forefront of additive manufacturing and advance our role as an Industry 4.0 leader in the region, we must continue to facilitate collaborations to drive innovation in our ecosystem. Singapore is an attractive location for international companies looking to scale up their activities in this part of the world. Therefore, it is important for us to seek ways to encourage collaboration and create synergies between these companies and our additive manufacturing players. One such example is a collaboration between Wilhelmsen, Ship Services and ThyssenKrupp to set up a 3D printing joint venture targeting the maritime industry. This partnership combines ThyssenKrupp's deep expertise in additive manufacturing and Wilhelmsen's long-standing maritime service and supply know-how. Together, they optimize the production and delivery process of 3D printed spare parts for the unique demands of maritime markets. their collaboration is testament to the growing demand for such services, which will continue to drive innovation and improve competitiveness in Singapore. NAMIC has also been instrumental in engaging key players to grow the additive manufacturing ecosystem through strategic alliances and collaborations. For instance, NAMIC and Osteopol have formed a strategic alliance for the purpose of establishing a point-of-care model that leverages the medical device company's leading regenerative implant solutions. Under this alliance, they will develop 3 market-driven strategic initiatives based on Osteopol's regenerative implant solutions. The aim is to grow the local clinical adoption of 3D printed implants to achieve better patient outcomes and lower healthcare costs. NAMIC and the Singapore Standards Council, overseen by Enterprise Singapore, have also been working closely with government agencies, academic experts, and industry stakeholders to develop standards to help guide the development and adoption of additive manufacturing technologies. For example, the first national standard, Technical Reference TR70, seeks to provide clear guidelines on evaluating the suitability of additive manufacturing as a manufacturing process for innovative applications. TR70 was developed with key stakeholders including MINDEF, SAF, DSTA, SUTD, and the Standards Development Organization arm of the Singapore Manufacturing Federation. TR70 will shorten the learning curve for end users of additive manufacturing technology and allow for the production of customized spare parts with faster turnaround time. In the next few months, the Standards Council will be publishing a new Singapore standard on the qualification of additive manufactured parts. This will be the only standard that uses a tiered parts classification with corresponding testing requirements to qualify the reliability and safety of an additive manufactured part, as well as a safety standard for additive manufacturing facilities. I encourage more companies to use these standards to deliver additive manufacturing products for your customers. The government will continue to encourage and support public-private partnerships to build capabilities in the future of manufacturing. About 2 months ago, Entegris, a global supplier of advanced materials and process solutions, embarked on a joint laboratory collaboration with A-STAR's Singapore Institute of Manufacturing Technology, SIMTech. This Entegris SIMTech partnership is an excellent example of how such cooperation can drive value and capture emerging opportunities for our local manufacturing ecosystem. The partnership aims to overcome current design constraints in traditional manufacturing by tapping on SIMTech's capabilities in additive manufacturing and Entegris' expertise in advanced materials science. This could lead to breakthroughs in 3D printing that will benefit a wide range of industries such as semiconductor and the medical technology sectors. It could also create more collaboration opportunities for local SMEs, enabling them to be part of the manufacturing value chain. As we continue to create more opportunities for collaboration in Singapore, we hope there will be greater impetus for wider adoption of additive manufacturing technologies. In the last 5 years, the number of companies providing additive manufacturing solutions and adopting the technology has grown exponentially, from a handful to more than 150 companies today. We look forward to this growing trend. I would like to encourage companies to explore the many possibilities that additive manufacturing technology has to offer. I wish all of you an engaging and successful summit. Thank you very much.
Thank you, Minister of State, Ms. Low Yen Ling, for your address. Further to what Ms. Low Yen Ling has said, collaboration is indeed key to success, and it's important to embrace and leverage on each other's strengths and pull through these unprecedented times. With that in mind, I would like to take the opportunity to announce a partnership between Entegris, a global leader in advanced material science in the semiconductor industry, and the Agency for Science, Technology and Research, A*STAR, Singapore Institute of Manufacturing Technology, SIMTech. They will be inking a strategic partnership to establish a joint research laboratory. This laboratory will serve as a technology center where Entegris will explore capabilities for developing new products using 3D printing technologies with the state-of-the-art modeling and simulation. We invite you now to witness this milestone MOU signing ceremony between Entegris and SIMTech.
Through public-private partnerships such as our exciting new joint lab with Entegris, A*STAR work hand in hand with industry players to co-innovate and develop new solutions to help them become more competitive. The SIMTech Entegris joint lab will generate both new possibilities in how product can be redesigned through innovation in additive manufacturing, as well as co-creating with other players in the additive manufacturing ecosystem.
Even before the current global pandemic, society was in the midst of a global data explosion arising from our world of interconnected devices. The semiconductor industry is in need of constant innovation to meet the demand for high-performance processors and memory devices. Innovative solutions developed at a rapid time frame is a must. Additive manufacturing is one technology which fits the bill by overcoming the current design, manufacturing, reliability, and cost limitations associated with the current technology solutions.
This collaboration will help to build our local additive manufacturing ecosystem where Entegris can undertake high-mix, low-volume manufacturing of high-value products in Singapore. A*STAR will work with Entegris to develop advanced powder processing, 3D printing technologies, and testing methodologies for the next generation filtration-related products in Singapore. We believe this collaboration will strengthen Singapore's presence as a reliable R&D hub for test bedding and development of new innovative processes and products in the world. This will be a solid testimony for our local research capabilities and strong partnership with the industry.
We are excited that our two organizations are coming together for this collaboration. Combining SIMTech's deep expertise in additive manufacturing with Entegris' advanced material science expertise, this would enable the exploration of a much broader array of innovations in product design, with the ability to simulate their performance before creating prototypes. Such research could identify ways to overcome the current design constraints in traditional manufacturing and lead to discoveries that benefit a wide range of industries, including semiconductor, aerospace, medical, and energy. With the signing of the MOU, we have fully embarked on the process of joint collaboration formation. We expect the collaboration to yield tangible results in early 2021. One aspect of this collaboration will focus on the development of additive manufacturing technologies to enable more complex geometrical designs for metal-based membranes and gas filtration solutions. We expect our research to lead to discoveries that will benefit a wide range of industries and emerging markets. We are certain this joint collaboration will position both SIMTech and Entegris as leaders in the additive manufacturing domain.
We wish the very best for a successful collaboration between Entegris and SIMTech in their journey together. As part of NAMIC's ongoing efforts to develop and expand the ecosystem and seed adoption, we run annual AM competitions together with our strategic partners. The most recent competition that I want to highlight today is the Global Maritime AM Challenge Rescue Vessel Design Competition. The competition was envisioned to spur additive manufacturing-enabled innovation in naval architecture and marine vessel design by developing new efficient designs for rescue craft, utilizing the advantages of AM to create a more compact vessel with autonomous capabilities, better designed for human rescue in difficult waters. This open global competition was launched late last year with the vision of eventually realizing a next-generation class-certified AM autonomous rescue craft, and this attracted design submissions from all over the world. The competition was jointly envisioned and organized by NAMIC, Lloyd's Register, AML 3D, Autodesk, and ST Engineering, with support from the Maritime and Port Authority of Singapore. The prizes for the competitions are jointly sponsored by Lloyd's Register Foundation, ST Engineering, and NAMIC. We had received a strong number of entries from around the world, and the jury selected the top 3 winners who will walk away with a prize of $30,000, $20,000, and $10,000 respectively. It is time now to announce the winners of this year's competition. First of all, let us congratulate our second runner-up, Kelvin Su, representing Kelvin Wave. He hails from the sunny island of Singapore. Kelvin will share with us more about his rescue boat design. Kelvin?
Presented by Kelvin Wave Private Limited. We are proud to introduce you our design KW5.78 to 60 RB unmanned smart rescue boat participate in NAMIC Global Maritime AM Challenge. KW5.78 to 60 RB has a length of 5.78 meters, breadth of 2.2 meters, depth of 0.87 meters. It has a fuel capacity 48 liter to last 4 hours of operation at the speed more than 8 knots. It can carry up to 8 personnel on board. KW5.8-60RB has a unique rescue zone that have a side shell cutout with lower slope to allow a smoothing recovering of personnel at sea without compromise the freeboard design. With the help of the electrical winch to hoist the man overboard safety net, this allow the rescue's operation to be totally remote controlled. Now I pass to Kelvin to share with you more.
Hi everyone, my name is Kelvin Shi. I'm an architect from Kelvin Wave Private Limited. I'm very delighted and honored to receive this award from NAMIC's Global Maritime AM Challenge. A special thanks to the organizers and support teams for providing us such a great platforms to showcase our innovative design and ideas which can be manufactured by 3D print. A new game changers in boat building industry and driving towards less waste, less cost and time in manufacturing process. It allows naval architects like me to pursue for high precision, better weight controls, and good qualities of boat design. We are looking forward to design and build more boats using additive manufacturing in the near future. Once again, we're grateful to organizers for offering us such a great and inspiring journey. Thank you very much.
Next up, walking away with a prize of $20,000 is Sovereign Group from France. Their submission, Sovereign Search and Rescue New Generation, has earned them first runner-up. Let's hear from their team leader, Matthew Collin.
Hello everyone, I'm Maxime Pachot, the responsible of the Marine Department at the Sovereign Group. At first, we'd like to thank the NAMIC team and Mahendran for organizing the competition and the ceremony. We are very proud as a young company, Sovereign Marine, to receive this second prize. It's very, very good news. As a very young company, it's always good to have such a reward to start with. We are glad to explain our design to anyone interested. Among them, the sponsors that might be interested into fabricating a prototype with us in 3D printing. And as such, we wanted to innovate in the search and rescue industry with this 3D printed fully multi-hull. It can be shipped in a 20-feet container. It has the 3 modes of piloting, either classic with a pilot inside, either remotely from another boat or ship, and fully autonomously. We have innovative axes like the butterfly doors, large. We have a net to deploy backwards to receive the people at sea. And the 3D printing was very important for that design, because the propulsion means are fully protected with tunnels now. All the compartments and deck can be fully printed. and we'd like to thank everyone that would be interested in advance to discuss with us this design. Thank you very much, and see you very, very soon.
Finally, coming in first place from France as well, we have Benjamin Khan with his entry Nemo 3D, fast and smart additively manufactured search and rescue boat. I'm sure he's eager to share with us his design with all of us today, so let's bring him on.
Well, it's a true honor to have won the first place. It was a very exciting challenge for me, and I did my best to fulfill the requirements. I can only deeply thank you all the NAMIC team and challenge committee members for taking the time to consider my application and appreciate its value. It is the first time that I designed anything linked to marine application, and it was a pleasure to discover this new field of engineering. I hope to see this vessel for real, and I'm sure it will prove to be very useful and save people. In fact, I can already imagine derivatives of this vessel that are fully unmanned, more compact, without crew or pilot seats. It could be a real game changer for rescue vessel designs. Additive manufacturing in marine application will definitely bring more design flexibility, shorter lead times. Most structural parts can be directly manufactured on site with one single machine. It allows a high in-house manufacturing depth. That's a dream for project leaders and engineers. I would like to thank also my family and friends for supporting me through this great competition. Thank you all.
With key players in their industries joining hands to innovate using additive manufacturing, such cross-industry partnerships will surely serve to take AM in Singapore to new heights. Now, with these recent developments in AM, many of us will be keen to find out how AM has developed on a global scale and what role AM plays in particular in Singapore. I'm delighted to introduce our esteemed keynote speaker, Mr. Tan Kong Hwee, the Executive Vice President of Singapore Economic Development Board. EDB has been instrumental in attracting global MNCs and strategic companies to build a world-class manufacturing ecosystem right here in Singapore. Mr. Tan has been part of this development and had overseen the growth of Singapore's aerospace, land transport, and marine and offshore industries. With years of experience in EDB, we look forward to Mr. Tan to give us a closer look. He will share with us on the transformative role of additive manufacturing in enabling a sustainable future in the post-COVID world. Let's hear from our keynote speaker, Mr. Tan Kong Hwee. Kong Hwee, it's indeed our privilege to have you here as our keynote speaker today. I'm sure you've got lots to share with our audience who are tuning in today. And so the stage is all yours. Take it away, Kong Hwee.
Thank you. Good morning. It is my pleasure to deliver the keynote at the NAMIC Summit 2020. The community that is gathered here today virtually, through a virtual conference, should be well familiar with the promising growth of the additive manufacturing market. It grew at a CAGR, a compounded annual growth rate of 27% since 2010 to reach $11.9 billion in 2019. By 2025, it has the potential to exceed $45 billion. Notably, these estimates do not include the investments that have been made on additive manufacturing developments by major companies such as Airbus, Ford, Adidas, and hundreds of other small and medium enterprises. And it also does not include an estimated $1.2 billion in venture capital that's been invested into promising additive manufacturing-related businesses. As a disruptive but complementary manufacturing technology to conventional production processes, additive manufacturing presents tremendous growth opportunities for the future. Such disruptions are not new to the industrial manufacturing landscape, as evidenced by historical revolutions such as steam engine-based mechanization, electricity-based mass production, and computer-based automation. Despite the positive outlook, I would like to touch on two challenges the world faces. The first is COVID-19. So the pandemic has caused tremendous upheavals in global economies and societies. Based on data from the International Monetary Fund, IMF, the global economy is expected to shrink by up to 4 or 5% this year, with businesses having to contend with these serious dislocations as the new normal. As a proxy of global sentiments, a recent McKinsey survey of manufacturers in Asia revealed serious issues they are struggling with. For example, sudden materials shortages, steep drops in external demand, and workers' availability. This is hardly unexpected, as public health outcome has been prioritized ahead of economic performance. Many countries have initiated lockdowns and safe distancing measures, creating critical supply chain. In uncertain economic conditions, weak consumer and business demand is a manifestation of that shift towards a preservation of finances. The second existential challenge for mankind is climate change. Now, this remains the defining issue of our time, and we are at a pivotal juncture where decisive action is required. After more than 150 years of industrialization, deforestation, and large-scale agriculture, the atmospheric level of carbon dioxide, which is the most abundant greenhouse gas, has increased by more than 40% since pre-industrial times, causing significant global warming. The resulting rise in sea levels and extreme weather patterns mean that mankind can continue to face further threats to our living environment and disruptions to the supply of food and resources. The fifth assessment report of the United Nations Intergovernmental Panel on Climate Change was categorical in its conclusion that human activities are the main cause of carbon dioxide emissions, and that rapid, unprecedented changes in all aspects of society is required to stem further damage to the environment. Black swan events like COVID-19 and this increasing awareness of climate change had drawn attention to additive manufacturing's role in reducing carbon footprint and ensuring resilient supply chains. Additive manufacturing can contribute on three fronts. They are material feedstock, manufacturing process, and the transport of finished goods. For materials, single-use plastics remain a tremendous source of pollution, with 90% of it never being recycled and up to 8 million metric tons of plastics ending up in oceans annually. In a similar vein, the environmental impact of metal mining is well documented. Greenhouse gas emissions from primary mining and metal production accounting for up to 10% of total emissions each year. Additive manufacturing offers a means of sustainable production very early in a product's life cycle through its ability to upcycle plastics and metal alloys, ensuring a circular economy of materials. In the plastic space, this is being taken up a step further through efforts on sustainable polymer feedstock, which are plastics made from renewable plant matter rather than petroleum. Careful consideration of feedstock choices according to end-use applications can reduce over-engineering. In fact, advanced materials, whether you use it in conventional or additive manufacturing, they have high performance properties but are typically harder to produce. And they have a higher carbon footprint and may not necessarily be the right material to use for every application. Unlike conventional processes, additive manufacturing's ability to produce multi-material parts enables optimization of function and carbon footprint. On the manufacturing front, conventional subtractive processes tend to result in up to 50% of cut-away material waste. As a controlled layer-by-layer process, additive manufacturing can achieve significant reductions in material wastage. For example, in the aerospace industry, additive manufacturing is predicted to save as much as 90% of raw material required in manufacturing by 2050. Moreover, the design freedom enabled by additive manufacturing allows for performance-optimized parts which require less feedstock, and part consolidation further increases material savings as well as reduces assembly processes. These efficient designs translate to lightweight but durable parts, which in turn leads to significant savings in fuel consumption and carbon emissions in industries such as aerospace and automotive, where routine usage of additively manufactured parts have been proven to reduce fuel consumption by up to 7%. Finally, the transportation component. It represents potentially the largest impact on carbon footprint reduction. The transport of goods and people, which primarily involve road, rail, air, and maritime, they account for close to 24% of global CO2 emissions, and it poses a serious challenge to the Paris Agreement goals. Additive manufacturing is digital in nature, and it disintermediates product development cycles to go directly from design to decentralized production located close to consumers and end markets. Studies have shown that a quarter of the $12 trillion global manufacturing industry will be disrupted and redistributed in the future due to growth of additive manufacturing. This distributed digital manufacturing paradigm not only results in shorter lead times, but significantly drives decarbonization as transport of goods is replaced by transfer of digital design files. Moreover, print-on-demand capabilities will eliminate the need for inventory stockpiling and associated materials use wastage. Next, let me share briefly on Singapore's additive manufacturing journey. Manufacturing has remained an integral part of Singapore's economy since our independence, accounting for close to 20% of our gross domestic product in 2019, and this will continue to remain at about 20 to 25% of the economy. In several industries, Singapore has established global leadership position. For example, we account for about 10% of global market for aerospace maintenance, repair, and overhaul. About 25% of the global output of semiconductor equipment comes from Singapore. We are also a top refinery export hub globally, and we are the fourth largest exporter of high-tech goods, such as pharmaceuticals, electrical machineries, and telecommunication devices. When Singapore first articulated seeding the additive manufacturing industry here in 2013, it was primarily motivated by our need to sustain competitiveness of our key manufacturing sectors and to secure additional value capture for the economy through the supply of additive manufacturing technology. To achieve this, the Singapore government has invested close to 500 million Singapore dollars to build a robust additive manufacturing hardware and software capabilities and talent expertise in a local research and development ecosystem. Today, for example, Singapore has received acclaim for the development of our very own laser-aided and wire-arc additive manufacturing technologies and the successful use of collaborative robots to 3D print large structures for the construction industry. In the software space, our research performers have renowned capabilities in powder-scale simulation of additive manufacturing processes, post-processing characterization, and non-destructive testing. Our educational institutions, polytechnics, institutes of higher learnings, and continuous education and training centers, they offer 7 tertiary programs and up to 60 accredited courses of additive manufacturing education and training, which together have graduated close to 1,000 additive manufacturing specialists and engineers for the industry. We also made efforts on building the additive manufacturing industry to create growth opportunities for Singapore. This involved attracting equipment and materials companies to establish regional headquarters, engineering, and R&D centers, as well as production facilities. To serve key end-use industries, we dedicated our efforts towards nurturing innovative startups and specialized service bureaus with deep additive manufacturing capabilities. And finally, we complete the additive manufacturing value chain by anchoring standards, testing, inspection, and certification companies in Singapore, as such services are critical to ensuring additive manufacturing acceptance and adoption in the industry. Today, we have had a good measure of success in building this industry, with close to 25% of global additive manufacturing companies having established some form of presence in Singapore, and close to 40 startups and service bureaus. To promote industry partnerships, enhance technology transfer, and scale industrial adoption, we established NAMIC as well. This is our National Additive Manufacturing Accelerator. As a conduit for government's efforts, NAMIC has played a significant role in the success of our strategy. It's engaged close to 1,900 companies, curating over 800 industry projects, providing up to 20 million Singapore dollars in funding for projects and sector-specific initiatives. For example, the Land Transport Authority, LTA, they formed a consortium with the railway operator SMRT and German MNCs TÜV and ThyssenKrupp to develop print-on-demand capabilities for our trains and automotive systems. Successful proof of concept have already been demonstrated for train gap filler brackets and aircon ventilator caps. Furthermore, an MOU has been signed with Mobility Goes Additive, a leading international network of additive manufacturing companies and research institutes to develop a database of spare parts which can be 3D printed for savings in lead time and inventory costs. In the marine and offshore and maritime space, Sembcorp Marine, a leading marine and offshore engineering group, has received certification for its capabilities in additive manufacturing repair procedures and 3D printing of large format marine parts. In a similar vein, the Maritime Port Authority and PSA of Singapore will jointly establish the world's first on-site additive manufacturing production facility specifically for port applications. Over 600,000 maritime spare parts have been analyzed and 100 shortlisted for 3D printing. These efforts will reduce the sector's reliance on external procurement and supply chain risks. In the past few months of COVID-19, much attention has been on the healthcare sector, given the global shortage of medical devices due to demand surges. Now, this is where NAMIC had worked closely with our hospitals, universities, regulatory bodies, and local companies to develop a Singapore-designed 3D printed nasopharyngeal swab for test kits. With a short production development cycle of less than 2 months, additive manufacturing helped Singapore rapidly increase our swabbing capacity. Our early investments in additive manufacturing and R&D have put us in good position to capitalize on the economic opportunities of 3D printing, shore up supply chain resilience, and most importantly, equip our industries for sustainable growth. Transforming our industries, economy, and society towards energy and carbon-efficient operations, harnessing low-carbon technologies as they mature, and pursuing effective international collaboration form the 3 key thrusts of our national long-term low-emissions development strategy. Despite one of the lowest carbon emissions per GDP dollar, Singapore remains fully committed to doing our part to address climate change. The low-emissions development strategy outlines our goal to peak emissions at no higher than 65 million tons of carbon dioxide equivalent by 2030. And we are planning to halve it by 2050 with a view to achieving net zero emissions as soon as viable in the second half of the century. Let me conclude by reiterating that additive manufacturing is a key enabler for a sustainable future for us. And we'd like to thank our industry partners who have worked with us to grow our vibrant additive manufacturing ecosystem. Many of them will be speaking at this summit, elaborating in depth on the economic and environmental benefits of the technology. I wish you all an informative and, more importantly, interesting and successful summit. Thank you.
Hwee, thank you for that wonderful speech and being with us here today. And we really, really appreciate it. And thank you for painting this global landscape, especially in the Singapore context of where our AM space is going today. So I wish you a wonderful summit. Grab a cup of coffee, sit back and relax and enjoy the rest of the summit. Now I'm sure everyone is eager to find out what our stellar lineup of speakers have in store for us. We will be bringing to you 2 sessions on sustainability with 6 amazing speakers from the industry, coming right up. Welcome back. Hope you have had a quick and good coffee break. I did too. I needed one. And for those of you who have missed the earlier session, fret not. You may find the stream under the Learning tab of the ITAB Connected platform after today's session. We'll make that available to you. We've heard from our keynote speaker, guest of honor, MOS Loh, and Dr. Ho Chaw Sing. Let's jump straight into our first session on sustainability. To helm this session, I'm pleased to introduce Mr. John Barnes. John is the founder and managing director of the Barnes Global Advisors, a company that specializes in AM consultancy. He's recognized internationally for his contributions to additive manufacturing, product development, leadership in engineering, with leading AM teams in medical, therapeutic, and aerospace industries. With a long list of achievements under his belt, including 14 patents and patents in application to his name, he needs no further introduction, I think. Let's welcome our first session chair, dialing in from the United States, where it's pretty late in the evening. It's Mr. John Barnes. Hey, John, how are you doing? How's the family doing?
Morning. How are you?
You're looking very sharp and nice and neat. Cool.
Thank you.
All set to take over the panel today?
Yeah, it should be. I think it's going to be an interesting one. I was not familiar with two of the companies, but they're pretty. I did my homework, and so they're very interesting.
Yeah, it's been a while since I last saw you in Singapore, John. A lot of things have changed, and we are in a different world today. COVID has really transformed, and we are actually doing well given the circumstances. How are you and family doing, and how is business as well?
We're fine. So we're in Pennsylvania, which I think has taken a pretty conservative approach through the whole thing. And my two daughters are going to school remote. They are involved in some sport in a very safe manner, and so things here are pretty normal as they can be. Let's say we really can't complain.
Yeah. I mean, so businesses are also transforming. I mean, for you, in terms of work and in terms of what you see, I mean, you have a global advisory. So what are your thoughts on that? Where are we now?
Well, I think people, some people maybe overreacted. And so we're seeing kind of more of a calming down, an acceptance of the situation that we're kind of in now. So, in general, as you know, I'm a fairly positive person. But I do see more positives than negatives. I mean, there's clearly some significant challenges, but we're a lot smarter in October than we were in March. So my hope is that. But I think there's a lot of silver linings. There's a lot of good learnings that have come out of it. A lot of good experiences that have come out of it. So personally, I've obviously gotten to spend more time with my kids. My dog is ecstatic.
Absolutely. I think that's great. I mean, always, as you say, we always find the positives in such situations. And I think we are coping very well, for sure. And so I think today we are focusing a lot on sustainability, and that's the panel that you're going to be helming. And you've got three fantastic speakers that we have curated together. So I'm not going to steal your thunder. So all over you to you, John. So take your stage now.
Okay, great. Thanks, Mahendran. I'm pleased to be able to be here, even remotely. It's a beautiful autumn day here in Pittsburgh, Pennsylvania. Leaves are changing. We're getting a little bit of cooler weather. It's always fun to be in Singapore. Last year had a lot of fun. Met some great people. Had a lot of good food. So hopefully next year, this time we'll be doing this in person. But had some great stories, some of which of people that I've met, have continued through the year. Some good business has come of it. And I think, kind of the interesting thing about Additive is it's a very global affair anyway. It always has been. So it kind of doesn't really understand boundaries too much. So I think I appreciate the silver linings as we were talking about. It's kind of a shared situation. So I think everybody on the planet is experiencing it, which, there's, I think, positives that can be pulled from that. We're using technology. We've adapted and we've been able to share experiences through the technology, kind of like we're doing today. So hopefully people, take some positives away from it. I'm very happy to be here and honored to be back as the session chair for the first Global Additive Manufacturing Summit Sustainability Track. I think the issue of sustainability is, certainly relevant to everybody today. And addressing that topic, we have three great speakers with us today. Before we begin, just a side note, if you have questions, you can post those questions on the question and answer panel, the Q&A panel on the right. And we can hold those and then answer the questions in the live panel discussion after the three presentations. First off, kicking off the session, we'll have Phil Ward, the CEO of Molyworks Material Corporation. A climate-friendly recycler, Molyworks envisions a sustainable future by providing a zero-carbon solution to metal waste by 2028. Close to his line of work, Phil will be speaking on going the upcycling way, turning waste metals into feedstock for AM processes. So while I was familiar with Phil and the crew at Molyworks, I had the pleasure of meeting Miss Sissi Chao, the founder of REMAKEHUB. She's going to be our second speaker. I've done a lot of learning about REMAKEHUB. It's a fascinating company who's taking on several large issues like waste in the fashion world and harvesting ghost fishing nets and recycling raw materials into useful objects, some with additive manufacturing. Ms. Chao is passionate about providing a circular solution for waste pollution. She is both an environmentalist and a sustainable fashion advocate, and her topic matches her passion, harvesting used fishing nets as materials for AM and new product development. She's kind of an incredible entrepreneur, and I think her presentation should be pretty fascinating. And lucky last, I learned something new talking with Mr. David Tan, the managing director of Netatech Group. Netatech is focused on smart agriculture. As Netatech puts it, high-tech farming can yield many times more than traditional farming. It is 95% science and 5% effort. I had really no idea. David has experience in water and sustainable engineering and is researching for a sustainable solution to solve present-day water and food challenges. David will be talking to us about sustainable manufacturing and food production for a greener future. So with those brief introductions, I think you've probably heard enough from me. Let's get our speakers and then to the live panel discussion.
Good morning and afternoon, everyone. My thanks to NAMIC for the invitation to share with you Molyworks' progress in producing high-quality, economic and sustainable metal powders for the additive manufacturing world. If we take a look at additive manufacturing growth, as most of you will be well aware, the market is expected to continue growing very fast to $48 billion by 2025, and many verticals in industry are already embracing the advantages of additive manufacturing. As the equipment gets better and faster, using more materials, and as more industries adopt the technology, the growth in the feedstock materials requirements is faster than the overall additive manufacturing industry. What we believe the additive industry would like to have in terms of their materials is obviously lower cost, because that's a significant part of the overall cost of the produced parts, since conventional methods of making high quality powder is expensive and also has a relatively high carbon footprint. Current production is not sustainable as it demands input feedstocks of mined and processed metals as a part of the linear economy. We want to enable an entire cyclic metals economy for all alloy types with an extremely low carbon footprint. And we want to enable the industry to print with more varieties of alloys which can be tailored more closely to the application. There are hundreds of alloys available for subtractive manufacturing, but very few in additive manufacturing so far. So we want to be able to produce on-demand, customized, rare and specialized alloys, for example, high-temperature refractory alloys, and wholly new alloy formulations for the industry. In the future, we also want to be local, because the distributive nature of powder production is going to be very important from many aspects, including resilience of supply, the speed to deliver, low cost, low logistics footprint, and we want to be able to upcycle scrap in place, creating the additive powder needed by the manufacturing industry, using its own waste metals as the feedstock. And finally, a big aspiration that we think should be embraced is to see no metal waste going into any landfill in the future. If we take a lighter note momentarily and we go back to the 1970s, there was a machine in Star Trek called the replicator, which could effectively produce things using energy and subatomic particles. And that concept was similar to what the 3D printer manufacturers have achieved now, except it's not subatomic particles, it's micron size metal powders and energy, and out comes the printed part. You can see in the quotes that some of the attributes of this concept so long ago are those that we might aspire to have for a 3D printing industry today, producing parts on demand and in place for repair, without going back to a base, a concept we call expeditionary manufacturing. The other part of this machine was about how to get those subatomic particles. The device could dismantle any object into particles, and this was the complete cyclic economy concept for space. So where is that machine today? Well, we haven't really seen it yet, leaving the feedstock still in the linear economy, where we mine metals, process them into billets, process that into wire, atomize the wire into powder, print the part, consume the part, and then dispose of it. Molyworks is now coming into this equation with a machine which can take scrap metals in any form and ingest them in a one-step process to produce metal powders for the additive industry. We add only energy, so now we're enabling the original concept of the cyclic economy, for metals in this case, with our device used in conjunction with the 3D printing industry. How does that work? We've invented a custom process through 5 years of research where we ingest metals through special feeders into a molten pool created with a plasma and atomized with our custom process using inert gas and some secret technology. The inert gas can be recycled because by its nature, it's inert, and out comes the powder for the 3D printing industry. Or we can print the parts ourselves by having various printers and capabilities in-house. The parts go on into the economy, and once used, they can come back to us. If we print a QR code on the part, then we can always trace who made the part and what materials are in it, which helps us with a more efficient ingestion of scrap in the future. If not, then we can still use the lab to make sure the chemistry going into the machine is exactly what we want it to be. So this process creates a very elegant circular economy for metals, working together with the 3D printing companies of the world, in the sense that the only thing consumed here is power, which can be very low carbon. In fact, where we're located in California, it happens to be 97% carbon-free electricity, and that's all that we add into the scrap to turn it into powder. We disrupt the metal industry by recycling, and we can distribute this recycling because the foundry that we've built is small, compact, and fits into a horizontal shipping container, all of which don't apply to current methods of making 3D printing powder. We can maintain high purity because what goes in is normally a good quality alloy, having been used in industry already, and we have an opportunity to still remove contaminants during our process, dilute anything that we wish to, even to add other metals via master alloy mixes. And when melted, it doesn't touch anything else but itself until atomized, producing very high quality powders with the chemistry that we want. We have one of these machines operating successfully in California, and we're expecting to locate the next one here in Singapore. So where will we get the raw materials for this mobile foundry, as we call it? Well, taking titanium as an example, it has a high scrap rate. As it happens, more than half the titanium purchased will be scrapped, partly because the buy-to-fly ratio in aerospace is so high quality titanium scrap is available at less than $7 a kilo, often much less than that. And the price of the AM powder is typically $150 or much more, depending on the grade of the powder in the exact alloy. So within that range, there's a lot of room for Molyworks to work and to obtain good efficiency to help the additive industry get the cost of its raw feedstocks down. The current pandemic obviously increases the awareness of such things as aircraft boneyards. Here's an example of a US Air Force site, and there are many others, such as in Mojave Desert. That's one of the many forms of scrap. But before we even get to cutting up and dismantling airframes, just pure industrial scrap exists at a very low price all over the world, wherever metals manufacturing exists. And we can buy that already clean, or we can have it cleaned. We can also ingest metal cuttings, which exist in very large volumes. You can see an example on the right there. We just compact them into blocks. And we can even ingest used metal powder through a custom process that we've developed, together with build plates and any other scrap from the 3D processes themselves. And we upcycle all of that into new powder for the AM industry. For some real examples, Here are some items we printed from powder made from scrap. Here's a drill collar from Inconel 718 material from the oil industry. We took a collar like that and chopped it up, ingested it into our machine. And here are some of the parts that were made out of the powder from that drill collar. These are oil field downhole flow diverters, which were then run successfully. And we've produced 21 alloys successfully so far, and we think that there's no reason we can't make almost any alloy with this process. If we look at the sustainability area more closely, this is data from the US Environmental Protection Agency, and I think nobody would be surprised to learn that reducing mining waste and carbon from the linear economy and using the metal that already exists to continuously recycle it with an elegant process which just consumes green power would be a very desirable state of affairs for the world in the future. And these are examples of the kind of savings that can be made for the benefit of the planet. If we look at a concept of the whole process, we start with sustainable manufacturing and we ingest all the types of scrap that we've mentioned into these recycling foundry machines, which are spread around the world and located where the demand for powder is or where the sources of scrap are present, ideally where both of those occur. We'd use just energy, and so we come back to the Star Trek cyclic machine concept to output feedstock, which can then be used with 3D printing machines, which again consume energy to produce the parts. This future world, which seemed like science fiction not so long ago, is possible now. The process has at least 10 times less carbon footprint than the linear economy today, even using fossil-based energy, and can be nearly 100 times less using low-carbon energy. We continue to evolve the technology as we work on deploying this in various scenarios, with the next one here in Singapore. We have ongoing Department of Defense contracts to help us evolve and test alloys and the technology. And more recently, we've added 8 commercial customers, as well as a contract with NASA for specialty space materials. Our team has a very strong background in metals, engineering, and business. Our founders are all still with the company, and all of us are very excited to bring this technology to Singapore for the benefit of the Asia-Pacific region. Thank you, and I look forward to the discussions.
Hi everyone, I'm Sissi Chao, the founder of REMAKEHUB. So today I'm going to share you the stories of how we turn trash into valuable products and material. So everyone asks me, how you start this startup. Well, I would always say it comes from my dream. And I've even painted here that I was holding the earth and surrounded by all those beautiful plants and animals. Then in that dream, I thought that I am the messenger of earth and I really need to do something good for the planet. And therefore, I started thinking about what I should do. Because my family business is related to textile, so I thought, why shouldn't we start with the waste, how we can recycle them and make them more sustainable and clean up the planet by these kind of innovative solutions. Worth to mention that REMAKEHUB is a mission-driven social enterprise, and we are highly committed to SDG goals from the United Nations, and we are also supported by UNDP and UNEP. So what we do is we can create a very interesting waste recycling solutions for different corporations and brands. Also based on your waste, we can develop and do some researches to make a very sustainable or recycled material based on your waste. So what else to the public is we can go to your communities and to educate the people or the schools about how we can be as an individual to join these cleanup or sustainable initiatives. So our team is, we have 5 members. We have a very small but very solid team. We have manufacturers, architects, engineers, writers, and me myself also is 30 under 30, and I'm well known as the princess of waste. So really, it's a very interesting nickname in China, where everyone calls me about this, the princess of waste. So in Asia Pacific, I also present UN SDGs to motivate more, partners or stakeholders to join these initiatives with us. Well, I think in this special COVID-19 time, lots of people, or let's say more and more people, understand how important is our planet and how important is about sustainability. However, around us, we can see all those wastes, including the single-use masks that protect us, right? So waste is becoming a very big global issue. And here, REMAKEHUB can deal with 3 main waste, such as textile waste, marine waste, like ghost fishing nets, as well as plastics waste. Because most of them, really only a very, very small percentage that we can recycle them. And most of them, like 73% of them, are actually going to the landfill or ended up in the ocean. So REMAKEHUB thought, as a new generation, we really need to use all these knowledges, to solve those waste issues. So that's why we come up with the slogan, say, waste left and remake right. So we wanted to use all those technologies and to solve out 1 or 2 or 3 single issues with waste. As we see here, our first initiative actually is called Remake Nets in Action. And this is to help and prevent fishing nets killing all these marine animals. And our goal is to recycle and remake 5,000 to 20K tons of fishing nets every year. So very, very proud that our first partner is WWF Australia. We have recycled their fishing nets and turned them into these beautiful, beautiful, amazing sunglasses for them. And we also used the blockchain technology to trace the entire journey on how those fishing nets was transformed into these beautiful sunglasses. And for this initiative, there are more than 200,000 individuals globally have joined and participated in supporting us turning fishing nets into renewable products. So we're very happy that people are really, really, getting engaged on this kind of interesting campaigns. So fishing nets can also be made into furnitures, as well as, for fashion apparel yarns. And for those yarns, you can turn them into socks, yoga and apparels, and also outdoor apparels. And for this particular project, we are also looking for strategic brands to support us. So here I want to show you guys in the very interesting initiatives that we do. It's called the 15th Plastic Hero Plugin. So those t-shirts that you see in these events are made from 15 plastic bags, and those medals are also made from 15 plastic bottle caps. And this is to create public awareness about how waste, which is a single-use plastic bottle, can become a very, very interesting and useful, lifestyle products around us. So here is another project we did to recycle textiles. We worked with Wagas, a very sustainable restaurant in China. So we turned their uniforms back into uniforms again. And these initiatives actually reduced 18,000 kilograms of CO2, which is really, really amazing. And people think, sometimes it's really difficult to separate mixed waste, we also face the same issue. So that's why we used different technology to mix the mixed waste into cement, and this new material can be used into lots of our living materials. So this can be also another way to recycle very difficult mixed waste. So REMAKEHUB empowers CSR and sustainable NDAs for different corporates, such as the brands that we worked with, Adidas, DBS Bank, WeWork, and on. We want everyone to join these initiatives and to really understand how sustainability can be in everyone's DNA. We work with charities. We go to the universities. We go to public, speak events, and to give people the concept of recycling. So here you can see we basically, since in 2018, we have already went to around more than 50 global events to share our ideas, to share our stories. And we got lots of support from different, big brands such as Len Crawford or DBS Bank and UNDP. So we are really, really proud that what to mention that DBS Bank has also made a mini stories on REMAKEHUB's inspiration, how we started and what we have done in the very beginning. And they named this mini movie called The Trash Princess. So it has also more than, I think, 50,000 viewers on YouTube. So thanks to them to spread, the positive impact in the globe. So me, myself, I really appreciate that there are so many different press and magazines supporting our initiatives. And I've been featured in BBC, CNC, and also Phoenix News and many other, news online as well as offline, to basically motivate everyone and individuals, to work on this project together with us. So I think REMAKEHUB is really trying to do business for good, not only for societies, but also for environment, as well as, for people and for corporate and business. I think it is the point that everyone should be engaged, and we should all work together because the clock is ticking and we have only 10 years left until 2030. Because the next 10 years, what we do is going to determine the human species' history for the next 100 to 200 years. So here I really, really wanted to say to everyone that, remake is always right. Circular solutions is always the best choice so far. Thank you.
Good day, everyone. I'm David Tan, the CEO of Netatech Group. Our company started 12 years ago, providing a platform for professionals, especially the younger ones, to co-innovate with us to find sustainable solutions in the area of water and food security by leveraging the multidisciplinary know-how of all these young professionals. In Netatech, we envision a future where cities are built beyond resilience and sustainability. We hope that it will be fully regenerative, productive, and produce sufficient food and water and harness nature's ability to maintain, to restore, and to improve our ecosystem. Our solutions and core services include consultancy, design, and build, and for the three nexus, namely water, smart, and farms. Now, projecting forward, worldwide arable land is decreasing rapidly due to urbanizations and climate change. The world has either too much or too little water nowadays, which are both not so good for agriculture. On top of that, supply chain disruption resulting from the current COVID pandemic exacerbates the global food security challenge. Last but not least, the increase of world population to 10 billion by 2050, coupled with the rapid declining numbers of smallholder farmers from the current 600 million, will make the situation even more bleak. Now at home, Singapore being a very small city-state of only 700 square kilometers, we produce less than 10% of our total food demand and rely heavily on imports from more than 90 countries worldwide. Our food security is based on the three baskets that you can see from the slide, namely imports, growing locally, and growing overseas. Singapore has set a target to produce 30% of our green leafy vegetables, eggs, and fishes at home by 2030. One of the ways to move towards our national food security targets is to innovate and to use alternative space for farming, such as repurposed factory or warehouses, car park rooftops, under viaducts, on building walls, and whatever suitable space we can find. To further stretch the utilizations of these limited spaces, we have to find ways to stack our farms vertically upwards or even build them underground. These are not common practices in the history of farming, and hence technology and farm solutions available currently do not study into these constraints. So on the brighter side, it gives Singapore an opportunity to embark on this exploratory aspect of R&D. Now, going forward, we will need to look outside of the industry and think out of the box and work with urban planners, engineers, and scientists to invent ultra-high yielding per square meter solutions for Singapore. Farming indoor in factories, farms underground, farms outdoor on the rooftop, on the vertical walls, and constructing dedicated urban farm buildings are all the potential possibilities going forward. Smart farm in a smart city cannot go without digital integration. Farm IoT, machine learning, artificial intelligence are all part of and parcel of these future farm technological stacks. We will see many small and decentralized farms work cohesively and cooperatively via shared services to produce food near where produce will be consumed, so to reduce supply chain wastages. As a result, we hope that these farms will produce quality food at an affordable price. This will encourage more communities to get into farming and together develop a vibrant food production industry. We will encourage more young professionals to join force and make urban farming a mega industry, just like FinTech or the Deep Tech. Sustainability and clean will be mandatory criteria in urban farming. Less water and energy will be used, and the production will also be less influenced by unpredictable climate. Now, what happened to 3D printing? Having painted all this background, I would like to describe to you how 3D printing can be adopted or exploited in urban farming. Let me walk you through two real-life projects we are embarking on to give you a glimpse of what the future holds. Seafood is one of the major protein sources. Singaporeans love it. And currently, most of our seafood supplies come from neighboring countries. Land-based fish farming is on the rise, and we will see more aquaculture farms go inland and stack upwards. Technologies such as recirculation aquaculture system, RAS, is not new. However, putting RAS in a vertical factory not many have embarked on it due to high costs. To stretch the goal further, beside building upwardly, we are now looking at growing upwardly within the vertical structure itself, meaning verticals within verticals, which will result in a multiplication effect. And let me elaborate further. Now, this is an example of a Krayling hatchery, which is vertical. The system is called Aqua Hive by the company called Ocean on Land. They develop vertical habitat trays that can hold 140 Kraylings in one tray, and is stackable up to 28 trays per nursery system. Due to the Kraylings being carnivorous in nature, this system will reduce mortality rate by at least 80%. If you look closely at this tray, you will notice it is a potential for 3D printing technology. By studying the habitual nature of the Kraylings, aquaculturists can then experiment and design different habitat structures to optimize yield per meter cube of water and reduce mortality rate attributed to cannibalism. As Kraylings grow, they will need to upgrade to a bigger space, just like we human beings. We can then devise new apartments for them. They will grow safely and happily. From this example, you can see that they are isolated yet able to socialize with their neighbors. For spaces such as rooftop, where load bearing is a constraint, we can create horizontal spaces for them to grow comfortably in as well. Now, in a normal earthen pond in Australia, Krayling harvested yield averages about 250 grams per meter cube of water due to cannibalism and high mortality rate. But in our vertical farm system, the potential is 15 kg per meter cube of water, and hence we can achieve 60 times more efficiency than the traditional earthen pond method commonly practiced worldwide. Now, how about agriculture? As for the agriculture industry, Asian green leafy is Singaporeans' main source of fibers. Stir frying is a common way of cooking these vegetables. Innovation for this industry are typically hydroponic, grown in high-tech greenhouses, indoor farm with LED lights, or vertical furniture within the greenhouse structure itself. This is our current innovation project called Vertical Food Stage. We utilize the unused gable end wall, which is the western-facing wall of the residential apartment, and to erect a modular structure whereby we can farm within each level of the structure vertically, and to maximize the usage of surface area. We use natural sunlight for these projects, and we supplement it with LED to maximize the yield. Now, when you look at it, even though this structure is very functional, but it does not look really attractive or creative if we were to populate this structure throughout the whole housing estates. In order to make this structure interesting and attractive, we can leverage on 3D printing technology to create interesting forms. It will be aesthetically appealing and yet lightweight to make our urban wall farms look like art installations. Now, architects and engineers can also explore sustainable material, such as bamboo, combined with 3D printed nodes to create interesting mesh structure. Okay, this is a project done by Dr. Carlos and team at Air Lab in Singapore University of Technology and Design. To sum up, farms need not be boring structures. As an example, this is an MS project built with lightweight hollow metal with 3D printed nodes and netting, which is now being displayed at the Garden by the Bay, Singapore. It's easy to install, structurally beautiful, and can potentially function as a rooftop farm. Now, as for the farm growing furniture inside the vertical farm, many components can be created and customized to improve efficiency and yield. Just like this American company called Farm Shelf has already leveraged on 3D printing for hydroponic pots, aerators, vents, and etc. In our research calculation of the yield of vertical farm, we are able to produce more than 10 times per square meter than the traditional farm. Now, how about 3D printing standard? Over the course of the last few years, additive manufacturing has emerged as a catalyst in reshaping product development and the manufacturing business model itself. But for 3D printing to truly achieve its potential, I believe that a set of widely accepted comprehensive standards should be developed, the absence of which may hinder large-scale adoptions of this technology. With the advancement of Industrial 4.0 and the digitization of inventory, AM will reshape product development and not just only for prototyping. Over the course of the last few years, additive manufacturing has emerged as a catalyst in reshaping product development and manufacturing business model itself. But for AM to truly achieve its potential, a set of widely accepted comprehensive standards should be developed, the absence of which may hinder large-scale adoptions of the technology. Now, with the advancement of Industrial 4.0 and the digitizations of inventory, AM will reshape product development and not only just for prototyping. Industrial standards for AMs are important because they define the rules and provide benchmark and best practice. Clear standards should also be provided as a mechanism for qualifying, certifying against those standards and quality. I hope Singapore can lead the way in establishing clear standards for AM, and that surely will contribute to the advancement of urban farming solutions. In envisioning the future, I would like to see more integration of technologies and designs for urban farms. We might see some of these tech applications emerging as masterpieces of architectures, just like some of today's famous city skyscraper. They are not only beautiful to behold, but very functional, sustainable, and productive. And most importantly, well-designed urban farms will attract the younger generation, facilitate interdisciplinary team collaboration, such as architects, engineers, life science scientists, and info technologies to produce food for many generations to come. With this slide, I thank you.
Thank you, David, for the vision for the future of farming, and Sissi Chao, Princess of Waste, exciting, and Phil, with all that recycling of metals for metal printing, right? So, and this is for your vision and leadership in the industry. We salute you, and we would like to hear more from you soon. So John Barnes is on standby to engage you in our live panel discussion. We can't wait to get started. So over to you, John, and the panelists.
Great. Thank you, Mahendran. So I think, I know I learned quite a lot in that. I took a lot of notes. And I think the issues of agriculture and waste are certainly timely this year. I think, Sissi, as you pointed out, the single-use plastic masks are certainly something I see every day now on the street, which is not fantastic. We talked about the replicator. We talked about, I love pollution to the solution. I think that's fantastic in vertical farms. As I mentioned before, as a father of 12 and 15-year-old daughters, I'm hoping that you're all very successful in what you're doing. A theme here is getting more from waste. And the old saying goes is one man's trash is another man's treasure. Sissi, I was reading about you, and I love kind of the story about your family being reluctant to tell people that you work with trash. Have they changed their tune at all? Are they happier with your choices now?
Yeah, it's actually a very interesting story. Like in the very beginning, I just came back to China, and I told my parents after 3-month internships in their factory, I said, okay, look, guys, I'm not going to do whatever you guys were doing. Now I'm going to clean up all the waste that you do, and I'm going to pick the trash. And they were like, what did you say? And at that moment, they cut all my, financial supplier. They said like, okay, if you're not going to take the family business, then you're done. You're by yourself, And I was like, okay, no problem. I'm going to Shanghai. And then after that, I started doing all my own startup, and there was once I was on the national TV on the news, and I sent the link to my parents. I said, this is how I do my business. And then it was like, they were very shocked, and they started very much supporting me and get to know how they can be more sustainable for their business and for their industry. So right now I get their full support. I'm very happy about it. Yeah.
Oh, great. Congratulations. So you don't have a technical background. I think you're well educated, but you're more on the arts and management side of the world, I think. Could you walk us through where 3D printing, how it's actually integrated into some of what you're doing?
Yes. Of course, my background is more related to art and management. But from my heart, I always wanted to know more about the technology side. So I did a very small consulting project in 2014. It was about 3D printing. So at that time, I knew a few friends that they're expert in this. So I started asking them, once I started my startup, I said, can we use, for example, recycled plastic, rPET, or recycled nylon made from fishing nets, or even LDPE, to make the filaments, and then we can produce some products such as like sunglasses, pen, and also furnitures. So we start doing projects in this way, and basically in my own startup, we produce the recycled material to make the filaments, and then the rest of the supply chain, they can just apply as they were doing before. Yeah.
Great. And it struck me at some point that maybe David could use some of your recycled materials to build the vertical, structures for his structures. How much of, one thing I'm always interested in is, I'm an engineer and I talk to people about technology a lot, but it seems to me with 3D printing both captures the imagination of people, but it's also very difficult to fully kind of comprehend. And I'm kind of curious between Sissi and David specifically, you guys, do you see this? When people, do their faces light up if you talk about 3D printing, or is it a challenge to describe not only the purpose of your company, but then 3D printing?
Okay. For the technology of 3D printing is not new. It's been there for the last, maybe 10 years or 15 years. I think one of the challenges is that, as you go into the mainstream and production, there are so many machines, type and material that is pretty confusing. For prototyping, it's kind of like, fun. And especially you can create something, that in the past you can only, manufacture by the professionals, right? And right now you can really 3D print whatever you design a computer in the 3D screen at home. So that's kind of like, excite the young generation. But as we go into the mainstream, I think that we really need to have a standard, and also, the materials of the system, especially when we into constructions and recycling. How do we ensure the the certification and also the quality of the end product that will meet the standard of the industry?
Great. So Phil, I'm not going to leave you out of the conversation, but I'm afraid as a metallurgist that I'm going to geek out on your topic. But you're melting metal in this process. Metals have always been highly recyclable. I think, what is it, aluminum? There's very little new aluminum can produced. It's all recycled. How hard is it to get people to appreciate what Molyworks is about? Do they just see it as another way to make metal powder? Or, it's a bit more than that, right?
Yeah, it's a great question. I think when we first talk about it, they see it as, just an economic way to make powder, which has advantages for the industry. But when people start to think about it more in a sustainable way, I think they get very excited then, because you're right. I think many countries, Singapore included, they do a good job on aluminium cans and domestic waste recycling. And we talk about that a lot. And what gets missed is that, despite all the efforts made, a lot of industrial metals are basically not recycled. There is a good rate, but it's not 100%. And the main reason for that is the facilities to do it are not distributed. They can't be small and mobile and planted around the world in the right spaces. So if you think about what Singapore does with a lot of its industrial metals, it collects it, processes a little bit, and then exports it. And even the US exports it to places that can reprocess it if they don't have the right mill or the right foundry for the alloy in question. So the whole industry is doing its best since many decades to recycle, but it's only achieving maybe between 30, 50, 70%, depending on the alloy, except maybe for gold and silver. When you get to the very high value alloys, then maybe we do a better job. But generally, there's a lot of metal going into landfills, maybe not here in Singapore, but it ends up in a landfill somewhere. And we think that by having a distributed, very versatile system, we'll be able to plug these in and immediately create a cyclic economy and recycle almost any alloy into materials for 3D printing. So today, the 3D industry is growing very fast and, enabling businesses like Sissi's and David's and so many others. But I think that the range of materials that's available is still not that high, especially if you compare it to traditional manufacturing. And I think that as time goes on, the industry will be demanding more and more specialty materials, and they want to be made locally. If you think also the challenges faced in Singapore by the industry, a lot of the powder is being flown in, and it's considered hazardous material under IATA. You have some duties, you have transportation costs, and then the whole cycle of getting that waste metal back to a foundry somewhere in the world, making new material, maybe making wire, then taking that to an atomizer and bringing that powder back to the 3D printer is a long cycle, which adds a lot of carbon and a lot of time to the supply chain. So I think the advantage that we'll be bringing is being local more than anything else and sustainable, so that we can use the metal that the world already owns and just keep recycling it the way that we do with aluminium cans quite well today.
It does seem like clustering recently, or these the fancy term agglomerated economies, seems to work very well, specifically for metals industries, maybe less so for polymers. But David, you talked quite a bit about standards and qualification and certification, and I know that is for my firm, that's one thing that we're constantly asked with. I mean, fortunately, business is good for that right now, which is a healthy sign for the industry, because people are grappling with this sort of situation. Could you give us some specifics of standards and where this would kind of, if these things were taken away or solved, what would you be able to do? And maybe Sissi, you probably have, I would imagine, similar issues as well.
Mm-hmm. Okay, so you can see that from my slide just now that, in Singapore, we have to innovate in terms of how to integrate our farms in the urban city. We are not a country like America and China. We have a lot of space, right? The entire Singapore is only 700 square kilometers, and we have about almost 6 million people. So the way going forward is to find creative way to architecture the urban farm into the fabric of Singapore urban city. So in the future, we're going to see urban farm, vertical farm that, clad the facade of the building like a fashion, right? Imagine that the traditional farm, if we were to populate the entire Singapore, that Singapore, 85% of our residents, they stay in the housing development board. There's a government, building, which are beautiful. But the thing is that if you were to clad industrial-like kind of farm everywhere, it's going to look not so beautiful. So we require stakeholder from the other industry, like the architects, right, to co-create together with us to build beautiful fabric and facade. And the other thing is about even recycling nets, right? When Sissi talk about the waste, maybe next time should maybe can help us to create the netting, the fabric that protect the farm from pests. Maybe like a fashion, and the farm is like the clothing that clothes around the farms to make our city beautiful. So there are some of the thoughts that I think Singapore is moving towards, and the future is going to be exciting for the younger generations.
I feel like we just created a new company. We should work on that. Sissi, I think with fashion, I don't know how much standards are there, but I would imagine that there are certainly some, flammability, et cetera, for, kind of personal safety. I'd imagine that this comes into play with what you're doing.
Yes, definitely. So because we really work with different industries, for example, like textile, plastics, furniture, toy industries, and many others. So every industry requires different material standards and certifications. So for us, we would usually on each project, we will make different standards or certifications based on their requirements. So for example, with let's say the eyewear industry, because it's contacting the skin on your face, so definitely it requires a certain chemicals. It has to be safe, or it cannot contain any kind of toxic chemicals inside. So we do have to send all our material for the laboratory testing, and also we have to get GRS, global recycle standards, and many other standards, and based on different industries. So yes, we definitely need to provide a very sustainable, safe, and also I think very well, let's say, cost-effective material for our client, because for us the most important thing is it is not what to do. Basically, it is how fast we can do everything through REMAKEHUB, because by 2030 we have only 9 years left. Now we're almost finishing 2020, right? Which we didn't do much, so we really need to work faster to catch up the time. Yeah.
Well, I'll ask a question from the audience. Sissi, one was, do you see Singaporean companies playing an active part working with your company to fulfill a circular economy role?
Yes, definitely. Because first of all, REMAKEHUB, we are working on an international scale, and we are trying to create solutions for different, countries and different clients. So with the Singapore, definitely we can supply them materials. And second, if in Singapore, if the facilities are, suitable, definitely we can also outsource our technologies to Singaporean companies so that they can do locally. And this is really, really good if every country can do a local, solution-based project and startups. Yeah.
Great. Let's see, Phil, there was a question for you, which is a good one. I know you're gonna like it, get prepared. What kind of investment is required to set up a Molyworks? Roughly what kind of operational footprint should be considered?
Wow, that's a great question. Yeah. Obviously, the exact numbers are a little bit internal to us, but let's say it takes millions of dollars to set up a facility. But once they are set up, they're extremely lucrative in terms of what they can process. So they're very small, but very high throughput. To give you an idea, if the audience wants to know, we can do about 80 kilograms an hour of powder. That means, you can consider what alloy you're thinking about and what price, and you'll see the kind of throughput that we can get. So it does take a significant investment, it's capital, but you would expect that in terms of, industrial equipment. And once they're installed, though, you only need, second part of the question, you only need about 1,000 square foot for the operation itself, powder making. And we say about 4,000 square feet total, which includes all the support to ingest scrap, process it, and process the powder that comes out. So it's a pretty small facility. We have one ready for us here in Singapore. And the only thing we have to do to install a foundry is connect the power and the inert gas supply. So these are going to prove very versatile. They can be unplugged and moved around, and they can operate in the future, we think, in remote bases, aircraft carriers, even in the battlefield to reprocess scrap and create feedstocks at the point of need.
Yeah, I think when I first saw it, it was envisioned to be in an ISO container and deployed, on an oil rig or, some remote, not easily connectable supply chain location.
Yeah, correct, John. Yeah, it's in a container, and then you just need, some support equipment around it when it operates.
How much of what Molyworks does is tied to additive versus other uses for metal powders?
Today, it's all for additive, but you raise a good point. Hot isostatic pressing, MIM, and even creation of binder jet are other possibilities. Then you have cold spray, of course, laser cladding. So, all of the powders that get produced have a home, but we've been focusing on 3D printing right now. In the future, I think people are already experimenting with binder jet using the fines from the powder production. So we have some of that. And we're expecting to get into cold spray and laser cladding quite soon. There's also technologies evolving in Singapore that are quite exciting. I think it was talked about in some of the keynotes this morning with robot arms building bigger and bigger parts and actually using the larger size powders, which is going to be, very interesting as well. And of course, these kind of things are going to consume more and more powder in the future. David's farms, if he's printing everything in 3D, is going to consume a lot of things, hopefully metals as well as plastics. And then for Sissi, a lot of plastic. So I think that, the potential for the industry to consume everything that these kind of equipments produce is very good, with very little waste, actually. And it is maybe worth noting that even if you have any metal waste that you don't really know what to do with, you can just put it back in the machine and make something else. So it's very versatile in that respect.
Well, the one thing that struck me is that not knowing Sissi very well, but she seems to be somewhat artistic. So if you provided her some metal, I'm sure she would figure out some pretty interesting things to make from it. There's one thing that 3D printing does is borrow a lot from nature in terms of structural efficiency. So, engineers are sort of artisans today versus maybe making zeros and 90-degree angles. When you're recycling the metals today, Phil, what are some processes that can be improved? What are things are you looking for help with?
Well, I think as the technology evolves, we would really, as a company, like to see more throughput gradually from the same device. I think we can do that. I think evolution of technology to produce more of exactly the size of the powder that's needed by the industry, adapting to that would be very good. And we have a technology roadmap that will gradually improve that over time. And then the rest is really just production engineering. It's not the core technology. Things like scrap handling, how do you cut the scrap into the right sizes for the machine? We're experimenting with laser cutting that's used for oil field decommissioning, which seems to be much faster than traditional methods. So there are a lot of things that can be done in processing powder, blending powder, and in scrap processing to improve the capability of the machine itself.
So David, one question I had for you was if you were going to ask this audience for something, what would it be? Is it back to standards and qualification, or would you have an additional request? Like what would be the thing that would take your company to the next level, given that you've got a pretty amazing audience right in front of you?
I think in Singapore, we want to encourage more younger generations, right? Because the last 50 years, we really didn't develop the agri-tech industry. And, this COVID-19 really bring out the challenge that we are facing. we thought that we can buy food from overseas. And when the flight all stops and border are closed, with 5 million people, what are we going to do with it, right? We need to develop our talent pool. I want to encourage the young generation, the professionals, to look into the agri-tech and co-create together to find solution for urban city. Especially for the next 30 years, more and more younger generations going to move from the village, urban into the urban city, right? So how are we going to provide and produce food enough for the 9 billion population in the future? So I think Singapore can lead in this area if we are able to produce food ourselves. 30% by 2030, we will be the lighthouse for the urban and populated city in the world. So young generation, come and join the bandwagon of food production in urban city.
Sissi, I kind of have the same question for you. How could this audience help you?
Followed by David, I think we are already in the young generation side. So we definitely motivate and we want to support more young generations or college students. Once they wanted to start a startup, definitely go for a social enterprise, or definitely go to choose something which is good for the people, for the planet, and as well as generate a very sustainable business model. Yeah. So for our company, we definitely would love, more companies or brands or corporates can start thinking about how to replace their virgin material by using more sustainable or recycled materials. And I think maybe in 2025, we can see lots of lifestyle products are already made by sustainable or recycled material in our, living environment. And this is what we are visionary in the future. Yeah.
Well, I can say, and I'm sure that Phil wouldn't disagree, but the keeping a constant stream of young people is something that 3D printing has always been able to do, but it's something that's going to have to keep doing. So the good news is that it has the attention. I hope that it kind of continues. It's kind of a global phenomenon. So the other question I had for you, David, was, currently you're looking in Singapore. Are you thinking about expanding, or you're going to solve Singapore's problems first and then move to the next location?
Well, Singapore will be our test bed for a typical, populated city. We already in the ASEAN, in Philippines, in the Thailand, and we'll be setting up branch soon in Vietnam. Okay, of course, China, or the urban city in China. I think that would be our targeted market. Yes. So in the next 5 years, well, we hope that we are able to introduce our technology to all the urban city in Asia, at least.
So a question I have around for all three of you, if you have your own perspective on this. I mean, we're kind of coming from different areas, although you guys are mostly closer together in Singapore at the moment. But when with the whole COVID situation, what did you see happen with supply chains? What did you learn, and what do you think will be different?
Yeah, I can.
Phil, you want to go first?
Yeah. Well, we definitely noticed that companies in Singapore for our kind of product began struggling because, they're trying to import powders because there's no powder production in Southeast Asia. So the supply chain starts to get long, and then they have higher costs as well, because even though air freight was still moving, actually the rates went up for materials like that. So I think the governments recognized it and mentioned it very strongly as well, that local resilience of supply became much more important, not just for metal powder, but we also heard it for even cements used in construction printers, And David even obviously mentioned it for food. That was a concern at one point. We're importing 90% of our food. What's going to happen now? Obviously, it was managed, thankfully, but the whole supply chain risk from black swan events became a big problem. And I think we're going to see a lot more emphasis on being able to have a resilient local supply of whatever we need on a regular basis. And maybe you could extend that to parts as well. You know, the 3D industry is printing parts. Hopefully in the future, the aspiration is parts on demand instead of parts in inventory, and maybe to some extent for food and other things as well. If we have a source of materials within the country, whatever kind of material that is, then I think everybody feels a lot more comfortable in industry that there will be sustainable activity despite any kind of major disruption. I guess we all started to rely on very, very good global supply chains, and suddenly they were threatened, and everybody started to change their opinion of relying on global trade instead of local supply. At least that's what we saw. And I think they continue to struggle a little bit today and wish that they had local sources for certain things.
Sissi, you probably have a very different supply chain. How much? I guess I'm kind of curious to ask you this question. You know, what happened? Was it different? How did you overcome it?
I think thanks to the country that I am staying now, which is the Great China. So I think right now in the COVID-19 time, on the way, I was reading the newspaper on the plane that, I think among all the countries, only China has a positive GDP during this time. And in terms of the supply chain, I think we are really in the center, the hub of manufacturing and supplying most of the products to the globe. So during the COVID time, I think China actually start recovering very, very fast. And we can definitely supply our own, domestic demand. And we can also supply for the outside international demand. And for based on my startup supply chain, what I understand is there are more international fashion brands are looking for sustainable material in China. And also domestically in China, we are also promoting more and more sustainable business models and circular supply chain in China. So I think it is a very, very bright future from my point of view, and especially in China. So we can supply domestically and internationally and more sustainable material. So this is very good. Yeah, I'm very happy.
Glad to hear it.
Just jump in at this point in time. I know that's a very intriguing discussion that is ongoing, and I do not wish to break the flow, but I think our audiences have been posting a lot of good questions that would be very relevant for you to take. So let's take a look at the first one. And so the audiences, you can continue posting as we will answer some of these questions. So the first one I have here is, which goes, what are the challenges of 3D printing technologies or applications that you faced during the implementation stage, and how did you overcome this? I think this is to all the panelists. Maybe Phil, you can start it off.
Well, obviously we make the materials for 3D printing. Specifically, our challenge was how to ingest scrap metal and make the right sizes and quality of powder that can work on all of the printers that everybody wants to use. Originally, I can share with you, when the machine was first constructed, there was almost nothing useful coming out. And the technology roadmap to develop it to where we are today has been quite long and cost us quite a lot of money. But now we're in a good position. I think that this can really benefit the world by distributing production everywhere. So our challenge was around the technology itself. How do you create exactly what the industry wants from incoming scrap. And we think we've solved that now.
Sissi, do you want to give your take on that one as well?
The first challenge, I had the same with the field, to think about how our material can fit in the existing different types of printers. And second for us is how we can add, because we produce our material, and recycled material has its own disadvantages. So how can we mix a certain percentage, for example, 30 to 50% of the recycled material with their virgin or existing material together? This is also a challenge for us to produce a half, let's say, recycled filament. Yes.
David?
Yeah, in the area of food production, we are right now embarking into printing food, alternative protein. So it's something that is more complicated than just the kind of standard, because it's taste, right? Different culture has different, sensory taste. It's difficult to change our taste bud that we have developed for the last 5,000 years of mankind, right? So this is something that the challenge is how to find the alternative protein structure, the right feedstocks, and fit them into the into the 3D printing and print the right, for example, a piece of meat, the fats, the tendon, and the texture, and then these are all something that's interesting but challenging that the industry is trying to solve. So we are integrating the production side as well as the food tech side. So these are some of the challenge that we are facing right now, and then we are trying to find a solution to that.
Yep.
It's very much a forward-looking kind of
All right, thanks, David. That's good. I think you've just talked pretty much about how the next question is also being phrased for all of you. So there's a question here that goes: do you think that people are more receptive towards sustainability efforts right now as compared to maybe a year ago or a decade ago? What would you think is the key factor that's pivoting this mindset shift? Open to the floor. Any one of you can take it.
Well, let me take the question, again, back to the younger generation, right? When we were in school, we are not taught so much about the green sustainability. We talk about more the engineering, efficiency and productivity during our time. All right. So the younger generation, when they go to school now, they are taught about sustainability, so it's the younger generation is much more understand the reason for sustainable, and they take action. That's important. They just not just talk, right? For example, in Singapore, we have a very interesting phenomenon. Our government built car parks, right? Multi-story car parks for parking cars. And for the last few years, we have found that the car park's top few floors are almost empty. And we asked the reason why, because the young generation find that it's not sustainable to drive a car, and they rather Grab or the Uber, and they find that it is contributing to the community, and then less carbon footprint, and therefore we need to repurpose the car park. And right now we are using the car parks for farming. Yeah, so this is really a paradigm shift.
Yeah, it's a great story. On our side, it's a great question, actually. I would say that we see a lot of interest now and a lot of movement from governments, from big industry, and also from investors more and more on the sustainability side. But I don't see it yet really from customers. I don't think customers are coming saying we need some sustainable materials for our process. Not yet. It will come, but not today. And maybe that's because the supply chain itself is still focused on economics. People ask us a lot, what's the price? And, how economic can you be? That's the traditional supply chain. but not necessarily how sustainable is your product yet, but it will come. And I think maybe the younger generation is going to drive this a lot more than the older. Coming from the older generation myself, I think there's going to be a big wave, as David says, of different behavior coming through from the younger generation. And if they start demanding sustainable parts, then it's going to flow through the whole supply chain. And there'll be some cost to that, of course. But as technology evolves, I hope that will be taken care of by the evolution of technology so that we can have both economic and sustainable products.
From my point of view, I think there are many factors all together, and that has brought us all at this moment. So let's assume if there's no COVID-19, maybe many other brands or companies haven't thought about sustainability yet. But once we have experienced COVID-19, we start to understand now we have to fasten our strategy change. Now we have to do a big change for the environment. So I think it is on the positive side of view, I think COVID-19 has slowing down our global business, but brought us a time to rethink what is really good and what is the new direction we should go for the next maybe 100 years. And for also, we talk about young generations, not only about college or teenagers, as well as, even kindergartens, they started teaching about how to separate your waste, how to recycle your home waste, and teach your parents as well, And in China, we started, we started the waste sorting last year in Shanghai. So adults cannot understand, but they were taught actually by their children. So children has to really think about, okay, I'm gonna live on this planet for another 90 years, right? But parents, you guys can probably leave earlier, but what you guys gonna leave me to live? Is it a sustainable green planet, or we are really going to the Mars, So they are thinking about themselves, and they do lots of strikes. You can see, kids are going strikes for global warming and climate change and stuff like this. Yes, definitely. And from the point, let's say, from the brand's perspective, they have already started the strategies on sustainabilities. They already proposed it 2 or 3 years ago. By 2025, they're gonna all go green, and they're gonna all go sustainable and recycle materials, such as fashion brands like H&M and Adidas. So they have a very, very good strategy on sustainabilities, and this is going to push the supply chain to change, and as well as consumers will be educated, and they will be more aware about what they are contributing to when they are doing a purchasing. It is not just buying a product, but being part of the solution.
Well said, Sissi. I mean, the future is, our kids are our future, and the future is going to be sustainable. Our kids are really thinking about it. There are a lot more questions that is still coming through the ITAP Connected platform, and I'm just going to hand you back to John to pick up some of those questions and engage you a little bit more further on it. John?
Sure. Let's see. David, what would be, let's see. Yeah, David, what would be the forward plans for Netatech Group, as we heard that the Singapore government is putting in strong focus in urban farming and sustainability?
Well, we have just built the probably the first kind of farm in the world that has a 0 foot mile. That is attached to the apartment block, and that would provide not only job, but also it cut down the entire supply chain waste. There's no cold chain, there's no transportation, provide jobs, and the most importantly is provide food security for our citizens.
And Phil, kind of changing gears here, but as a theme, how does waste processed metals compare with current industry metals?
with current industry metals, or?
Yeah, I think the question's intending to say, do you see an impact because it's a recycled metal versus a virgin feedstock?
Oh, yeah, absolutely. Yeah. I mean, the process to recycle metals in this way is at least 10 times more green, if you like, or lower carbon than traditional methods of manufacturing the same metal, and 100 times lower if you consider that you use just green energy in the process. Today in Singapore, we have to use gas-generated energy. In California, we're lucky enough to have almost carbon-free electric power. But in the future, everybody's going to have access to more and more renewable energy. So the carbon footprint of this kind of process is going to go down and down. And then if you think for a moment about the current recycling process, you have to collect the scrap and then ship it out after usually some pre-processing and send it right back to a mill that can handle it, or a foundry. And then you have to send it to be made into wire typically, and then send it to another company to atomize it, and then send it back to the 3D printing company. So all of that is introducing delay, carbon from transportation. We all know transportation is the second biggest carbon footprint creator after power generation in the world. So, we're creating carbon and adding cost all the way in those efforts. So by having a distributed local machine that can just do that, it's going to transform the sustainability of the whole process. At the same time as, reusing the resources that the planet already has. I think it doesn't make any sense to mine a metal and then put it in a landfill and mine another piece if you could actually just use what you already have. We do it with aluminium cans. We just need to do it in a sustainable way with all of our metal waste. And our goal, I put it in my talk, our goal is, in the end, just to have no metals going to landfill at all. There should be no reason for it.
Well, great. I think we're out of time. I'm going to hand you over to Mahendran, but Sissi, David, Phil, thank you very much. I hope to actually get to meet you in person next year.
Yeah, thanks,
I hope your families are doing well, and you have a good rest of the session.
Okay, John.
Thank you.
Mahendran.
What an insightful and informative session. I've really learned a lot about how AM can help us achieve zero waste in metal production and the fashion industry. With food security being a pressing concern for all, the potential for smart agriculture is indeed valuable as well. But of course, that's not all there is to our talks on sustainability. Our second session will focus on sustainability in the additive manufacturing industry. So stay tuned and join us after the break. And welcome back. I hope you had some time to check out the ITAP Connected platform, and please continue doing so over the next couple of days. And thank you for joining us now for our second session on sustainability. Our next session chair taking the lead is Ms. Nora Toure, founder of Women in 3D Printing, and dialing in from the United States with a decade-long experience in the additive manufacturing industry. She has a deep understanding and experience of the manufacturing ecosystem, with a passion for working at innovative companies, driving social value through technology. It's my pleasure to invite Nora. Hi, Nora. How are you doing?
Hey, Mahendran. I'm doing great. How are you?
You're looking lively and energized as ever to helm this session, although I know it's really late in the night. I hope the kids are all in bed. But thank you so much. Over to you, Nora.
All good. And thank you, Mahendran, for the lovely introduction. So before we are kicking off the session, I would like to welcome all of you to post any questions that you may have on the Q&A panel that you can see on the right. So we will be having a live panel discussion at the end of this session, and I'm sure speakers will be very excited to answer all of your questions. So please do stick around for this live panel. All right. So first in line, we will have with us Mrs. Sherry Handel. Sherry is the Executive Director for the Additive Manufacturer Green Trade Association, also known as AMGTA. So the AMGTA is a global nonprofit organization founded to promote the environmental benefits of AM to key industries and to the general public. So the AMGTA promotes the adoption of 3D printing as an alternative to traditional manufacturing methods, which is what Sherry will be speaking on in her talk, Additive Manufacturing, A Path to Sustainable Success. Following Sherry, we will have Dr. Karsten Heuser. Dr. Heuser is the Vice President of Additive Manufacturing at Siemens Digital Industries. So Siemens strives to assimilate 3D printing in industrial production while integrating software and automation solutions at the same time. Karsten will be speaking on, is 3D printing a clean technology? How can it impact sustainable manufacturing and consumption? Closing the session, we will have Dr. Blake Perez. Blake manages nTopology's APAC business and presence. So he's an expert in the field with a PhD in engineering product development from the joint collaboration between the Singapore University of Technology and Design and the MIT International Design Center in Singapore. He is a manufacturing specialist with experience from semiconductor to oil and gas with a focus on design for additive manufacturing. Blake will be sharing with us on how implicit modeling can enable emerging applications through the digital transformation of AM. Now that we know our speakers a little bit better, let's welcome Sherry back to start off her presentation.
I'm Sherry Handel, Executive Director of the Additive Manufacturer Green Trade Association, also known as the AMGTA. The AMGTA was launched last year at Formnext with a mission to promote the environmental benefits of AM over traditional manufacturing. I came on board as the trade group's first executive director in late February of this year. While the economic and technical superiority of additive manufacturing is well known within key industries, its sustainability benefits are often less well understood. For this reason, the AMGTA was launched to promote the environmental benefits of AM over traditional manufacturing. The AMGTA is a global and unaffiliated nonprofit organization open to any additive manufacturer or industry stakeholder that meets certain criteria relating to sustainability of production or process. My role is to build and grow this new industry trade group worldwide and work with our member companies to take on the sustainability challenge in AM. It is exciting to see sustainability in AM gaining momentum as more companies strive to improve their eco footprint. To help the AM industry advance sustainability, we need solid, reliable sustainability data and metrics. I'm working with our founding member company representatives who serve on the AMGTA board of directors to provide the AM industry with this much needed research. Companies in the AM industry can support independent, rigorous, and ongoing research by joining the AMGTA in our mission to improve sustainability in additive manufacturing. Our goal is to publish AMGTA's research findings and share them with our members, industry, and the public as soon as each research project is completed. This published research will help spread the word about the positive environmental benefits of additive manufacturing while also revealing areas that we as an industry need to improve upon. The AMGTA's focus is to serve as a key industry resource positioned to help the AM industry rise to the challenge of sustainability in AM. There are several positive environmental benefits of the additive manufacturing process when compared to traditional manufacturing. Most notably, there is considerably less waste in AM. Existing research on sustainability in AM tends to focus either on materials waste, machine energy use, or machine emissions to manufacture a part. However, there is limited published research that considers life cycle assessment or life cycle analysis. Both terms are used interchangeably, but they mean the same thing, known as LCA. LCA is a comparative study of the environmental impact a part or product has throughout the stages of its life, from cradle to grave. The AMGTA is addressing this lack of real research by commissioning studies that include LCA, which will analyze a part through each phase of its life, from resource extraction, material processing, manufacturing, distribution, use, and end of life. This research will determine at a granular level by what amount AM is an environmentally improved manufacturing process. LCA means fully considering what it takes to produce a metal AM part. For example, from the ore that's mined out of the ground, processed, and refined to an AM powder material through the gas atomization process, transported, and then the energy used in the machine to produce the part, the emissions produced all along the way through the various stages, including transportation, assembly, and there are many other steps that I haven't mentioned here, up and through the part's eventual end of life when it is no longer useful. We want to fully understand what the environmental impacts are all along the way, from raw material extraction to end of life. The AMGTA has 2 research projects that are now underway. In June 2020, the AMGTA commissioned our first research project through the Technical University of Delft in the Netherlands to review existing literature relating to the subject of LCA within metal AM. For this research paper, we have selected a leading researcher in the field of sustainability engineering who has a strong background in AM research. His team is currently examining and reviewing academic research that's already been published. We felt a summary of what research is currently out there would be a good starting point as we begin to generate new research topics for future consideration. The AMGTA will release key findings of this research along with recommendations on future research that needs to be conducted. This research will help us understand and determine what our eco-footprint is now, while also revealing what we need to focus on in the future to make the AM industry even more sustainable. The AMGTA plans to publish this literature review paper in early November 2021, and it will be available to our member companies, industry stakeholders, and to the public at large. It will be posted on the AMGTA website at amgta.org. The AMGTA is also working with a leading research university in the United States to commission a research project case study, which is an LCA of an additively manufactured aerospace component as compared to an identical cast component. This groundbreaking research will be one of the first real LCAs that has ever been conducted, directly comparing an additive part to a cast part. This case study will be published in time for Formnext 2021, where the AMGTA plans to announce key findings of this important research. Although our initial research projects, the literature review and the aerospace component study, are focused on metal AM, we anticipate that our future research initiatives will look at research on polymers and other materials that our membership is interested in. This future LCA research that will be commissioned by the AMGTA will be determined by our member companies. To date, the founding member company representatives who serve on the AMGTA board of directors have decided what research projects the organization sponsors this year and through 2021. As we grow our membership, we anticipate that we will have a broader membership base of diverse types of companies within the AM industry, which will most likely result in future LCA research studies focusing on both metal AM and on polymers. In the interest of full transparency, all AMGTA research is funded exclusively by our member companies through annual membership dues. Life cycle assessment research allows us to better understand the environmental impacts of AM, the good, the bad, and perhaps even the ugly. We don't think it's necessarily a bad thing when we find a particular area is of real concern. This just means that we have an opportunity to rise to the challenge and find innovative and collaborative ways to mitigate this problem. The more that we know, the better we can pay attention to those problematic areas with negative environmental impacts and make incremental improvements over time. It's like anything. If you don't know what you're up against, then how are you going to be able to make any improvements for the better? The research findings are not always expected to be positive. However, I'm confident that every AMGTA research project will ultimately lead to actions that will have a positive impact on our environment and our industry. Sustainability cannot be achieved in a silo. For sustainability to transition from wishful thinking to impactful results, we will need to partner with industry players along the value chain and beyond. Company leadership needs to consider many stakeholders as they develop their sustainability goals and objectives, including their employees, customers, vendors, suppliers, communities, governments, nonprofit organizations, certification agencies, educational institutions, and other constituents. Sustainability is an ongoing journey. By this, I mean that the path to sustainability can always be improved. One of the best ways for AM companies to become more sustainable in their operations is to become ISO 14001 certified. ISO, the International Organization for Standardization, develops and publishes international standards. The ISO 14001 certification specifies the requirements for an effective environmental management system, EMS. ISO 14001 certification is available to manufacturers, service providers, and other organizations. It provides a framework that a company can follow to improve its environmental performance throughout all of its operations. As more companies in the AM industry adopt the ISO 14000 certification, not only are they improving sustainability within their respective companies, but they are also serving as industry leaders in advancing sustainability in AM. As the ISO 14001 certification is becoming more well-known, there are more certification companies offering training, audit, and certification services for environmental management systems. Sustainability initiatives can start with any employee within the company, sharing an idea on better ways to do things that are less negatively impactful to the environment. That employee could be anyone, the shipping clerk, the receptionist, an engineer, or the CEO. But the sharing of an idea by an employee is not enough. The key to creating a sustainable culture within a company is for leadership to continually encourage employees to voice these ideas and suggest initiatives that will improve the environmental footprint of their operations. For successful idea implementation, companies need to set up a process whereby employees are encouraged to contribute ideas. Each idea is carefully considered, feasible ideas are implemented, and there's a way to communicate with all employees in the workplace that the idea has been implemented and show how it's making a difference in improving the company's sustainability. To have the most impact, management needs to consistently evaluate and improve sustainability efforts on an ongoing basis. Visionary industry leaders are constantly challenging their team members to find new ways to reduce waste by repurposing or recycling used materials, improving the manufacturing environment for their workforce, shortening the supply chain to reduce the distance parts and products travel, finding innovative ways to use new materials, including biorenewables, and other creative solutions to become more sustainable. These important initiatives have led to an increase in value-added parts, products, and services. Striving for improved environmental sustainability is an ongoing process. Each incremental step a company takes will help pave the way for our industry. Together, we can implement improved processes and procedures and ensure that these improvements are maintained, measured, and monitored. By commissioning and publishing rigorous new research in the field of sustainability and AM, the AMGTA intends to augment and facilitate these continued efforts by industry leaders. We all witnessed during the COVID-19 pandemic how supply chain disruptions and logistical hurdles were countered with print-on-demand efficiencies, shared CAD files and other resources, as well as the leveraging of community relationships to provide PPE such as face shields, testing swabs, and medical equipment parts to hospitals and healthcare facilities locally and globally. Just as the AM industry harnessed the passion of its employees to tackle the challenges presented by the coronavirus to make a difference and save lives, we can also advance sustainability in AM to save our planet. This resilient industry has learned how to leverage AM in ways that we have never seen before. As the AM industry continues to grow, we will continue to iterate and evolve. We are well positioned to advance sustainability in the AM industry to improve our collective environmental impact globally.
A warm welcome to all the additive colleagues in Singapore. It's an honor for me to present at today's Additive Manufacturing Summit, calling in from our Additive World Center here in Erlangen in Germany. Let's talk about sustainability and the role of additive manufacturing. I want to put it into the context of three main areas: about designing the product, about the role in manufacturing the product, as well as in generating new business models for these 3D printed parts. We as Siemens follow up a full holistic approach from the digital twin of the product, the digital twin of the production, automating the real production, and then feeding data and the digital twin of performance back into the systems to continuously improve. What does it mean? It's about a comprehensive, seamlessly integrated tool set of software to design, to simulate these products. It's about automating the machines and the production lines with components and software. And last but not least, it's about industrial edge cloud digitalization solutions to monitor and have a continuous improvement and high quality of the production process. But let's step into three examples where I can explain to you the role for the sustainability of additive manufacturing. Here you see the three examples from the left to the right. It's about the design and to really reduce the weight and the use of material. And let's start with this first example. Just take a gearbox and you have a bracket for this. In conventional manufacturing, this is produced with 9 individual parts in a massive way. With the right tools of additive manufacturing, it's possible to generate these bionic structures with the right tools. With this, you're lowering the weight by 50 to 60%, having the same stiffness, but only one produced additive manufactured part. Let's go into the workflow as I explained from left to right from the digital twin of the product. So you need to incorporate the old design into our Siemens software suite and then reiterate by the right tools for generative engineering to come from the old design to these bionic structures as you see here in the short movie. However, before going into the printer, you need to be sure that there's no distortion. And this can be already simulated in the software, and then you can already find out if there's any problem which may occur later on in the production process of the printer. Even further, this software is seamlessly connected with the latest machines from Fasoon, and these machines producing these parts are as well automated with our latest and greatest automation technology. The result is, as I mentioned, only one part, less material consumption, and reduced weight for the later performance, a big impact into sustainability. Let's move into a second example, which is in the area of the production in itself. Here you see one piece on the slide, which is a duct, which is to cool the print head of an HP latest industrial printer. This part is normally produced conventional, and you have a lot of distortion and chaotic pressure flow through this part that it's not optimal to run the printhead under full speed. Now we move through the same workflow, and let's have a look what the impact is. Starting once more with the workflow in Siemens NX, where you start with the old design, and then you have a software suite, which is STAS CCM, a software which is optimizing the part by its flow. So you have some corner conditions you keep constant, and then you start to come up with a fully reinvented design for this part. Here already you can simulate the performance of this behavior of the part, but not always you're really sure if you can print it. You need features in the software for the digital twin of the production to find out if this is part really printable. We have design checkers. We have the digital twin of the HP machine in our software incorporated, that at this point you can already find out where later problems may occur in the printing production process. Even further, you can put automatically serial numbers onto these parts, and you can nest automatically these parts to use and have the most comprehensive density in your printer for the actual print job later on. This part is then incorporated and used in the latest HP printing technology. It's increasing the flow by 22%, which at the end leads to better performance, higher speed, or lower power consumptions of the printer itself. If you then consider, as we show here in the digital twin of production, that you have many of these printers working, it's gaining a lot of productivity. And it's making the shop floor much more sustainable in the production area. Let's move into a third example. Our colleagues from Siemens Energy are very active in the terms of service business for additive manufacturing. Just assume how many parts are stored worldwide in all the service logistics center and never used. All the energy is already used. The material is already used, and you store it for decades. This is pure waste and inefficient way of using material and energy. With additive manufacturing, you can do it differently, which is shown here in the example as well once more from Siemens Energy with Solocon and with EOS. It's about storing the parts digitally and then printing while you need it for the service. And here you can go through the same workflow end to end. You start with a lot of parts, which is a conventional part. You reiterate, and the colleagues in the Siemens facility in Finspång have done this quite well. They started with a repair process. In the meantime, the full burner is printed with an even improved structure and inner structures to really optimize the gas flow. As well, you need to take care that you don't waste any energy by printing and having waste in the original printing process. Therefore, we have tools created where the digital twin of the machine is already incorporated in our software. So you can optimize how many parts can I produce. How do I attach support structures accordingly? Even further, you can simulate if there would have any distortion coming up in the process. The key word here is first-time right printing. If you want to print the part when you need it, it needs to be first-time right. Once more, this is seamlessly connected with the latest EOS powder bed fusion printers, and these printers are running within Siemens. Overall, within Siemens entities, we have more than 200 printers overall running in 45 locations. And once more, the result is an additive manufactured part, and this part generates a higher sustainability impact because you produce it when you need it, and it even has an improved behavior in the later on production and the field of the gas turbine. So if you want to experience all these things, just some weeks ago, Benjamin Moy and Raimund Klein, my colleagues in Singapore from Siemens Digital Industries, they have done a tremendous job and opened an advanced additive manufacturing transformation center in Singapore. Benjamin is now starting to welcome you as member of the NAMIC, but as well all the Asian companies being interested to start the journey on industrial additive manufacturing. You see the information here on the slide. Please feel free to contact Benjamin Moy. By that, I want to thank for your attention, and I'm looking forward to the later panel discussion with my colleagues coming in the next talks. A big thank you for listening to my speech at the NAMIC conference. Thank you.
Hi, everybody. My name is Blake Perez from nTopology. I'm excited that NAMIC has us here today to talk about enabling emerging applications through the digital transformation of additive manufacturing and what role nTopology has to play in that space. I want to give you a little bit of background of nTopology first and kind of talk about what we do and where we help in the additive manufacturing space. So as we know, technological evolution in the factory has really changed the industry as we know it. So we're used to this certain image of what a factory might look like, and it's come such a long way in the past decades, right? We've gone from a very manual process to a very automated, very advanced place, and additive manufacturing has really driven a lot of that in the past few decades, right? And the problem here is that the digital tools, our digital tool chain hasn't really kept up with this advancement. And so legacy engineering software was never really built to solve today's problems, right? Even seemingly small complications with a CAD model weren't so important with older systems. But when we look at additive manufacturing and we look at the suite of advanced manufacturing tools that are available today, these small issues can have large implications in the integrity of your model. And so much work is spent to repair these models and make sure that we have things that are printable today. It really slows down the design process. And so that's what nTopology is looking to help solve. We provide a computational modeling platform for design, simulation, and advanced manufacturing. And so there's three things really that we enable. One is high performance and reliable geometries. So these are really advanced things that you might see in the aerospace, automotive, and medical industries. A field-driven approach which unifies design, simulation, and manufacturing knowledge. So finally, a platform for all of this data to work together, to play together nicely. And when you combine those two things, what we end up with is a reusable engineering workflow that can be integrated into an engineering tool chain enabling automation. And what that means is because our models are so much more robust than legacy CAD systems, we can start to automate a lot of the design work, not the creativity from the designers and the engineers, but we start to automate some of the maybe more repetitive tasks that plague our CAD workflows today, right? So what we're trying to enable is unbreakable geometry, regardless of complexity. So no matter how complex your part is or can be, our software can enable that. And the reason we need that today, of course, is because of the geometric freedoms that additive manufacturing has enabled. So on to the topic of the conversation today is how does nTop platform contribute and transform businesses during the pandemic and beyond, right? So I think that's particularly relevant today. How does nTop platform help enable digital transformation? And I want to start with our company's mission statement. Our mission statement is to empower engineers to design transformative products, right? So additive manufacturing has enabled the production of these products. How do we also enable the design both efficiently and effectively, right? So let's look at additive manufacturing in general, and I want to list a few of the different I think characteristics of the parts that we make with additive manufacturing, right? So if we think about these parts, they're oftentimes high performance, right? So the reason we use additive, the reason we leverage the geometric complexity is because we want super high performance, whether that's super lightweight, super efficient. When we look at heat exchangers, maybe for medical, really high performance in terms of how a body might accept a medical implant, right? And because of that performance, because we're trying to push the boundaries, we end up with high geometric complexity, right? So really intricate parts, potentially really small features, very organic shapes, things that we just can't really do with traditional manufacturing. And this also results in high cost, right? Obviously, the price of additive manufacturing has come down significantly in the past decade. But when we look at still part-to-part cost, it's still relatively high. And as a result, we also need high quality. We need to ensure that the parts coming out of our machines are of high quality. We don't want to print multiple parts. And then also the places that we're putting these parts, in aircrafts, in automobiles, in human bodies, they must be of high quality, right? And then high compliance. You know, these industries also have their own sets of regulations. We need to make sure that these parts were not only manufactured to specification, but that they continue to remain in specification throughout their service life, right? And so all of these things, in order to ensure that, basically require a team of people, or if not teams of people. So high performance, you know, you have your engineering team. High complexity, you have your manufacturing team, people who are experts on the machines. Cost, you're bringing in the business side of an organization. Quality, engineering and testing, and then compliance, potentially third-party regulatory bodies. And all of these people need to be able to work together. And that's what I really want to talk about today, is how we have over time enabled these different teams, these different people, I think, to work seamlessly together in a single platform, right? So I want to show a few slides that kind of show how that narrative has evolved in the history of nTopology, which is, you know, only a few years long, right? So this is an image that I've taken from a webinar that I think we aired maybe about a year ago. And the story we were trying to tell here, this was a part that was built in collaboration with Cobra Aero. They actually make parts and components for UAVs. And what we're doing here is we're combining all of this different engineering knowledge into a single geometry, right? So we're taking thermal data, we're taking pressure data, fluid flow data, and stress data. We're combining this all under one platform to modify and enhance the geometry of the final product. And I think this was relatively new at the time. Obviously, this is a standard design process to try and involve all of this data, but being able to involve it all under one platform and letting that data directly drive geometry, I think was a big step for us and a big step for additive manufacturing design space, right? And so we're enabling effectively designers, engineers, manufacturing engineers, all to work together here. And that has since grown, right? There are other there are other teams that want to be involved, right? So in this slide, we talk about a single physical part, but there's multiple data sets that can integrate into nTopology's nTop platform, right? So in the top left, we have our topology optimization result, the result that comes from that algorithm. We have the native solid model that exists in the implicit geometry kernel that nTopology provides. We have that FEA, CAE validation data. Whether you do that CAE analysis in nTop platform or you do it in another, you can bring that data in. And then we have the CAD model, right? How do we export a CAD model to a PLM system or an existing CAD package that any of our customers are using? Potentially toolpaths, CAM files, surface scans. So can we bring in that point cloud from scanning the part after it's been produced? And then also CT data, right? Can we bring that in directly if we need to inspect the interior of a component? And what's great is so we've taken the manufacturing engineer, the simulation engineer, the design engineer. We started to involve the testing engineers, bringing in that test data, as well as sort of the CAD IT infrastructure as well. And it's just this great platform for everyone to work together. And that has become more important today, I think, than ever. We have the most distributed workforce that we've ever had. People aren't coming into the office. People aren't able to kind of work the way they used to. So by consolidating platforms, I think we're really helping to enable this sort of digital transformation. Right, and so this is kind of where we are today, right? We look at the evolution of that narrative of a couple teams working together. This is bringing all of this data all under one roof. So CAD geometry, simulation results, experimental measurements, the material properties of the part or the material that we're printing with, additional engineering data. It might be thermal. Who knows? And really, you know, we like to say if you have engineering data, if you have data from your process, you can bring it into nTop platform and make it actionable. And the results of that are optimized geometry, highly advanced geometry. It's also validated. It can be simulated. We can create these custom applications, these custom workflows that are used in medical space, dental space because of the robustness of the platform. Then some automated processes like jigs and fixtures, being able to automatically create these things from an input geometry. So enabling all these applications, and kind of right there in the middle is nTop platform, providing unbreakable geometry, field-driven design, and repeatable workflow. So, and that's really the enabler to connecting all these pieces of data to final parts, final workflows that are used by our end users. Right. So I want to also talk about, just kind of work through a few of the parts that we've designed in nTop platform, or that our partners or customers have designed, and talk to the idea of how multiple people or multiple domains were involved in its production. So the first is an exhaust pipe reinforced with isogrid stiffening ribs. So I think there's actually an error here. It's not automotive. It's used in another industry. But the density of the ribbing structure on the outside is graded nicely based on the stress considerations and the performance requirements. You have as well topology optimization in the bracket region that's also involving a different team just to make this part lighter weight and consume less material in production. It's also functional. There's sort of a filter feature in some of the inlets with lots of perforations that are on the inside. It's a little bit hard to see. But they're there on the inside on the left of the part. And so you have material reduction, you have engineering analysis, kind of lightweight strengthening of the part, and the introduction of functional features inside. And all of those things really require a different domain expert to come in and be able to operate on this part. And we're able to produce it. You know, here's a heatsink that uses a graded infill structure that is self-supporting, but it also allows for great thermal efficiency by maximizing both convective and conductive heat transfer, right? So we're able to grade the thickness of this complex structure as you move up. So it's thicker at the bottom, bigger pathways for thermal conduction. This geometry also kind of helps the air flowing through it, improve the convective heat transfer, so we're able to reject more heat into the atmosphere, into the environment, improving the overall efficiency of these parts. And there's a lot of work that we've been doing in the heat exchanger space. It's very, very interesting. And the last part I want to show is this brake caliper that was designed by one of our partners, Yamaichi Special Steel in Japan. It uses topology optimization to drive the thickness of the part. So it's a little bit hard to see, but if I gave you a cross section of this part, it's thicker and thinner in different regions based on where it needs to be for strength considerations. But also you can tell that it's beautifully designed, right? So the framework for the design and the aesthetic was established by the designer. And then the mechanical engineer can come in behind that and strengthen that part where it needs to be, so it can be lighter weight, but still sufficiently structurally strong. And this is where all these different types of teams come in and they work together, right? So, you know, we're in the sustainability track, and I want to talk a little bit about that. Like, what does any of this have to do with sustainability in terms of bringing people together to work together, creating these parts? I thought about this for a while, and I know that I could have the same conversation that I think you've had before, where we talk about, okay, additive manufacturing is sustainable because we're making things lighter weight, and that reduces fuel consumption. And it's great because we only use the material that we need. And all of that is true, and we've proven that. The problem I see with that is if you peel back the curtain in that process, you have these really interesting parts, these really advanced and optimized parts, but you have teams of people spending so much time to actually design these parts, right? So the frequency at which these things occur is very low. I feel personally that within Top Platform and these other advanced digital tools that you see today, we'll see more and more of these advanced designs that are ultra sustainable in the long run, whether you're looking at the part itself or the system that it's a part of. And that's what I'm really excited about. So I know that you know that story, and I wanted to kind of talk about what we're doing as just as a company, but as an industry to push the needle forward towards that goal of sustainability. Really appreciate you joining me for this conversation today. If you have any questions about my talk or about the platform and want to learn more, don't hesitate to reach out. My email is here, and I look forward to answering any questions. Thank you very much.
Sustainability is the way to our future existence, as you heard from all of our speakers. And with AM, it's going to make a difference for sure. So thank you, Sherry, Karsten, and Blake for that good sharing. We will now move on to our live panel discussion with Nora and our speakers who have a lot more to share. And so I'm going to hand over the stage to Nora. Over to you.
Thank you, Mahendran. And thank you to our panelists. So Sherry, Karsten, and Blake, those were really great presentations. Thank you for that. I'm very excited to have you here with me during this live panel. So before we actually move into the live panel, we would just like to send a reminder to all the attendees to post your questions. I will have the privilege to start with some of my own questions for a few minutes, but I do promise that we will keep some time for your questions as well towards the end of the panel. So please do send your questions, and we will select a few of those towards the end. And for anyone who joined us mid-talk and missed some of those great presentations, no worries though, because we are recording all of those sessions and the presentations, and they will be available for you to review right after the panel. All right, with that, I would like to jump right away into my questions. So there are definitely multiple aspects of additive manufacturing being an environmental friendly technology, whether because, the less material in production, so additive versus subtractive, but also because of what it enables, so shortening the supply chains and producing closer to the end user. And so my question to all of you is really that I would love to hear what it means for you, what sustainability in additive manufacturing means to you and your businesses. And as I said, I would like to hear from all of you, and maybe Cherry, the question will be a little bit different for you because you do see it through your users and to your members of the nonprofits, so the organization. So for you, the question might be a little bit different, but I would like to start actually with you, Karsten, if you could share a little bit about what, again, sustainability in AM actually means for you.
Yes, thank you, and good morning here as well from my side. Yeah, as I mentioned as well in my talk, I would summarize it. It's more performance, more productivity with less material, less CO2 emission, and less energy consumption. However, it's not an easy calculation. If you want to have an honest assessment for sustainability, you need to start at the very first beginning. So we all use this powder. This powder needs to be produced. The powder needs to be processed. The parts need to be produced. And you need to look on the full life cycle from producing the powder till the end of the part in life, in the product life cycle. For us in Siemens, this is very serious to take additive manufacturing as well in the context of sustainability. Just look on our Siemens Energy business. Their CO2 reduction is a huge impact, and their additive manufacturing is doing its part as well for burning hydrogen and other materials in the future for the decarbonization of the world. Take it on our Siemens mobility area, where we are supplying trains in all over the world, and spare parts for these trains are stored in logistics centers, and you don't use it. You have already consumed all the energy. So for our digital spare part business, it's very important. And on the other side, we develop the tools which enable this sustainability with the software to really reduce waste and production and better performance and better parts, while the software increases the additive manufacturing part for the design.
Thank you. No, and that's very important. Those are really important points. Thank you. So Blake, Sherry, do you have insights as well on this question?
Yes, certainly, and thanks for having us as well. From my perspective, I'm really hyper-focused on basically taking the case studies that we've seen over the past, let's say, 10 years of additive manufacturing, where you have this really interesting part that when it's put into use, it's helping reduce emissions somehow, whether it's a lighter weight aircraft part, lighter weight automotive part. The issue here, and I spoke about this in my conversation earlier, is that it takes a really long time and it takes a really big team to design these parts today because it's really difficult. And so our goal as a company is to really make that whole opportunity commonplace, right? Make it very easy for engineers who maybe don't know so much about additive, teams that are just getting into additive manufacturing production, and make it incredibly easy, incredibly fast to innovate and create these things way faster than we've been able to do in the past, right? And that's just a consequence of the people who have done it in the past. They're pioneers, like just kind of doing things that were never invented before. So that of course takes a lot of time, but now that we understand the pain points in that process, trying to alleviate those, and I hope that in the next 10 years, we see a lot more of those parts, not just as a case study of, look what we did, but just like in production, in the things that you have at home or things that are flying in the sky.
Thank you.
So my perspective is more on the research side. We do know, of course, additive manufacturing gets a lot of attention because of the lightweighting, the design optimization, less material used, and there's several other key benefits. But do we really truly know how less impactful additive manufacturing is versus traditional manufacturing? And so to really get a good understanding, we need strong, robust research that's independent and rigorous, and that life cycle assessment that was talked about earlier, and I talked about it in my talk as well, is really key to really truly doing a comparison of apples to apples of the whole cradle to grave process for both the conventional as well as the traditional, as well as the additive manufacturing of a part. For instance, a case study to really truly get a good understanding of the differences and where really are the benefits. And I think that's going to really be dependent on what it is you're making. It's going to be dependent, of course, on the types of machines used. There's differences with polymer and metal inherently in the manufacturing process. So, and there's a lot of challenges with both. So I think we're going to learn not only what we're doing really well, but where we're really struggling and where we really need to do some work. So that's where this organization, the AMGTA, the Additive Manufacturer Green Trade Association, comes in. So our goal is to help advance sustainability in AM by providing that rigorous data, the metrics that our industry needs, and our members support that effort by helping us determine what we decide to commission, what research projects we decide to actually delve into so that we can provide the industry with the information that's needed.
Yeah, and actually, Sherry, I have actually a follow-up question for you on that. So clearly, sustainability, I would say, like, from what I can tell, is in some regards, it's a bit like diversity. In some regards, it's not always the priority number one. And again, with my organization, Women in 3D Printing, that's definitely something I'm saying that it's not always priority number one, even though I think it should. And so for me, sustainability is kind of in the same realm. And so I wanted to ask you actually, how do you have this discussion with those companies? How do you make it top priority? What is your selling point here?
Yeah, the startups certainly, small businesses are challenged because there's a lot of restrictions from the standpoint of cash flow in particular, and trying to meet the metrics for the investors and getting their companies off the ground and proving out their milestones. And so all of that I totally respect and I understand. I've built and grown 3 different startups myself, so I understand that very well. I think one of the great things to be said here is that it doesn't take any money. It can be very simple for small companies. You don't have to get ISO 14001 certified from the get-go. You can encourage your employees to submit ideas on ways to improve and lessen the environmental footprint of the operations of the company. Just one idea that's implemented can make a difference in the overall result. And so having some sort of structure in place that could be very basic, it doesn't take a lot of effort, to encourage employees to submit their ideas and then to vet those ideas and discuss them and decide which ones to move forward with and which ones are realistic and implementable. And then also sharing with the team what is actually being implemented and why, and then monitoring the results of that implemented idea so that people can see the difference it's actually making. And so that's a really simple process that, again, doesn't take any money. It just takes time to actually, take that process and make it happen. And then sharing those results. I think that's the really key part, because if you just take the idea and then the idea sort of mysteriously goes away and nobody really sees it implemented or really understands that it's being under discussion and then maybe it is going to be implemented, just having them involved with the whole process and not only on the forefront, but through the process to see that it is implemented and how it's actually making a difference, I think is really key.
And actually, Karsten and Blake, I mean, on the flip side, do you see your end users, do you see your customers coming to you with this specific sustainability aspect and priority in mind? Do you see that more and more?
Yeah, I think from our side, definitely. Sorry, Karsten, I'll just jump in and let you have it after.
I guess you like my question.
Yeah, well, I mean, for us, from our internal perspective, I agree with Sherry, right? Like, it's not always a priority when you're a young company, right? It's hard to make that a priority. But for our customers, especially in aerospace and automotive, that sustainability aspect is directly tied to business value, which is awesome, right? Like, you don't have to go in and convince someone to save on fuel costs because that impacts bottom line directly. So there are scenarios, I guess, where sustainability and profitability go hand in hand. And so it's been really interesting to see how we support our customers in developing parts that do both of those things at the same time.
Yeah.
Yeah, perhaps to add to that, I think on sustainability overall, it's a priority in many companies. And because as well, sustainability is a topic of innovation and technology. So if you want to be around in 5, 10, 15, 20 years, you better should look and focus on this. Besides having the ideas of people to implementing, I think it needs to come as well from the top. It needs to be a top strategy in the companies. Talking about specifically additive manufacturing, I think 5 years back, and Blake mentioned this, while people started with the tech center, they didn't consider yet if this full workflow is lowering waste, CO2 emission. This comes now, while all the companies are starting now and our customers are running into serial production. So you don't produce anymore one prototype and it takes you tons of material and costs to make this prototype happen. Now having the prototype, the business cases are proven, but going into serial production is a total different game. And there you can really focus as well on sustainability, and then you have big impacts. If you produce one part, this is something which is probably not yet a top priority, but in the big serial production, this becomes a priority. And I think looking at my company, this is really driven from the top as a strategy from the company, decarbonization, CO2 emission reduction. And this will be a huge driver for additive manufacturing to bring this into a large industry technology. So better startup companies should focus in it because it's a huge argument to win more and more customers for your additive manufactured parts.
Yeah, that makes total sense. Thank you for that. Totally agree with you. And actually, I'm going to steal a question from one of our attendees. So how important is the integration of software solutions with hardware for sustainability solutions that you are driving? And the question is a double question, asking for good examples that you can share. And maybe, Karsten, we're going to start with you.
I can give you 2 examples. One example is waste. If you go into the additive center, you probably find out that still in prototyping you have a certain number of waste trials you need to run a part because you have deformation, you have errors in the process. Now, if software is doing a simulation job as we're doing to predict deformation, to simulate already if you could have a systematic error by artificial intelligence, and you don't need to run the wrong process, as I mentioned in my talk earlier, first-time right printing, you can directly have an impact, and this is driven by the software. Second example is the digital warehouse area. How to manage a digital warehouse, you need to have operating systems, you need to have platforms, how you manage this, how you transfer data from A to B. If you don't send physical parts around in the world, you need to send digital parts around in the world. So you need to have platforms. We have, for example, from Siemens, the AM network for this. Security, you need to transfer it. You need to have these operating systems of the platforms. This is pure software as a service. So 2 examples. I think software is the important factor to make it happen in the end of the day. And therefore, software becomes more and more important in this area.
Yeah.
Yeah, absolutely. I think another big portion of that, adding on to what Karsten just said, is like, how do we capture data around testing and validation of the physical component, right? So there's this question in additive manufacturing of, once I produce my part, how do I verify that it was produced to the specifications of my design file? right? So we need to be able to, first of all, verify that when it comes out of the printer. And that's really a software solution. It's, you have your printer hardware, you have maybe a CT scanner hardware, and then you've got to put all of that data together back in software with your original design file of record. And then beyond that, let's say 5 years down the road, 3 years down the road in service, when you inspect that, you need to do that again. And you need to be able to correlate that data together and say, hey, this part is still in specification, it's still performing the way that we intended it to or not. Without that, without that software backbone, you can't really guarantee the lifetime of the part the way you can with that data stream, right? So I think as we push the performance, not in terms just of engineering performance, but performance in terms of lifetime as well, software is incredibly important when it comes to sustainability and using those parts longer and longer.
You probably also need to integrate it a bit more of Industry 4.0. I'm thinking sensors, especially if you want to keep track of the full life of a part being on the field. It's probably going to go through sensors at some point. Okay, thank you for that, Blake. Sherry, do you want to share on this one as well? Are you seeing some good examples of software and hardware kind of combination here?
Yes, we're commissioning our first life cycle assessment project with a major U.S. university to compare an AM metal aerospace component manufactured versus a traditional casted part. And in that process, of course, the design and the design optimization is huge in the AM side of things. So it's going to be really interesting to see how the LCA comes out when you're looking at this particular example. It's going to be, we think, very revealing, but until we do the study, we won't know. We're just at the beginning stages, but we plan to announce this, the results, the key findings at Formnext 2021, which will be in person, hopefully. Everything, is planned to make that release known at that point. And then we'll share, of course, the full paper with anybody that's interested within the industry and also the public at large.
Perfect. Yeah, looking forward to this. Absolutely. And I would say the AMGTA is fairly new. I mean, this is an organization that, so Sherry, can you share again, when was the organization created?
Sure. The organization was launched at Formnext last year. I came on board in late February, so I've been on board about 8 months now. And so a lot of my work has been focused on working with our board of directors on the research projects we commission, as well as membership recruitment, and just a lot of the, getting the organization off the ground and working on with marketing and communications and doing some press releases. We're announcing our tomorrow, actually, we're announcing our member companies. So we're putting out our third press release this year, and then we'll have a fourth press release in November announcing our first commissioned research paper, which is a life cycle assessment study of existing literature to see what's out there for additive manufacturing in metal AM, and then also what is out there in terms of LCA for existing conventional manufacturing, to get a better understanding of the lay of the land and kind of where we are now as a benchmark. And we've gotten the first draft. We're expecting the second draft soon, and the final paper will be delivered around the third week of November, and we'll be announcing that.
Okay, so you've been quite busy, obviously, in the last year. And so fairly new organization, so obviously doing a lot of very important groundwork, but at the same time, you are doing all this work while we are all in the field having to actually produce part for our users. And so I can definitely see a world where we get all the studies, we get all the information, and we get everything we need to truly be sustainable in our industry. But again, in the meantime, we still need to get going and producing parts because our customers need those. So as my next question is mostly for Karsten and Blake, how do you do it right now? What is missing? what was missing yesterday, and where do you see like the biggest gap, and what would be like number one that you need out there in the field to be able to get there, to get to the point where we're fully sustainable today? It's a very big question. So can we phrase it as like, what is missing today?
I think this is indeed a big question. And I would phrase it like in the lean development in the past. I think there's no start and no end for this sustainability topic, because it's a continuous improvement. Mm-hmm. And we need these academic studies, we need these consortia to really analyze the full life cycle, and then we will find out new pain points where to improve. Just take the recycling of the powder. How many times can you reiterate the powder in the metal process that you don't use? Some people do it 3 times, 5 times, 20 times till you need to and how much energy do you need to spend to do this? So I think there's a continuous improvement process needed year over year, like you're improving productivity in your factory over years. You need to improve sustainability year over year, and this will not end. And the big topics are, for example, productivity of the machines. If you have now 1 laser, then you have 4 laser, then you have more and more productivity speed in the machines. This is something which needs to develop further to gain more applications which are lower in costs, and therefore we need to have higher productivity of the use cases to extend our area. If you compare additive, it's not making an impact today, because the percentage of the manufacturing by additive versus the manufacturing overall is tiny. So it's about accelerating, it's about teaming up as additive community and make it happen. We need to make it happen first to have an impact, to be a serious part of the manufacturing industry. And therefore, I think we have a lot of homework to do. Bring it in more and more applications, bring it into the normal world, and then continuously work on our homework to make it more productive and increase sustainability. And I'm pretty sure we will have the same discussion how to improve it in 5 years from now as we have it today. With probably other levers already, we may have solved a lot. So looking forward to these improvements.
Perfect, thank you.
Yeah, I think it's like a pretty incredible, like high-level view of what it's like. It's like we're missing nothing right now, but we're at the same time missing everything. It's continuous improvement. We continue, I think, to uncover opportunities with respect to sustainability and additive, and then obviously, growing sort of additives market share and manufacturing in general is huge. I want to provide an answer that's a little more zoomed in, right? So just for a little bit of variety, right? There are certain things that we start to understand not until we start doing them. For example, we've been having a lot of conversations with people involved in footwear, and one of the things that we offer as a platform is the ability to tailor the sort of lattice structure or mesostructure of a part to give you a certain mechanical response. So if you think about midsoles in a shoe, you have these different regions and they all have kind of different compressibility, different mechanical response to give you like high performance in those different regions where you need it. And with additive and lattice structures, you can come in, you see a little bit of work in this area with companies like Adidas, New Balance, putting out these additively manufactured shoes. It's not obvious, but when you think about sustainability there, you're now printing this midsole in a single material or maybe just 2 materials instead of 4 or 5 or 6. This makes recyclability totally different, right? It allows you to take that part or recycle this midsole a lot easier, turn it into other materials and getting rid of that whole separation process, right? And I don't think that opportunity was obvious a few years ago. So that, yeah, I think that's kind of part of that continuous improvement story where we'll never be done. We will continuously uncover new opportunities, but that's the exciting part of it.
Thanks.
Yeah, I like what you say about this example because it's also ties to what our users and what our customers are doing and how this entire question of sustainability and recycling, specifically in this case, is handled in this industry. Like, how is the footwear industry actually handling recycling? Because there's only so much we can do as manufacturers, but if then the actual end users are not following through that and actually have processes in place for their own sustainability goals, I mean, we should still do what we need to do, but it's no longer in our hands. In some ways, or it should be maybe. So I guess that's another question for a completely different topic. Yeah. So I think we're going to have. There you go. Hey, Mahendran.
Yeah. Thank you. Sorry, Blake. Thanks so much for that perspective that you've been talking about on the evolving sustainability issues. So I'm going to just jump in quickly with some questions here from the audience. They have been eagerly posting lots of questions, and it's now time to answer some of them. I will highlight some, and Nora, then you can take over the rest. So here's the first question that's coming out, and this is to Sherry. From your perspective, what extent is AM a sustainable manufacturing process, and which areas could be improved to enhance its sustainability?
Well, I think it's clear in certain industries like aerospace, the lightweighting is having a huge impact on reducing carbon emissions as well as fuel consumption. By lightweighting different parts within an aircraft and extrapolating that over a fleet of aircraft, you can really easily do the math and see the significant impact it's having. But how do we do that with other industries? What's automotive looking like? What's, and then you can go through in each industry and then there's a lot of questions there because it hasn't been researched. Again, this research is just at the beginning stages, and we'll know more when this literature review paper comes out, what currently is referenced in the research as being a significant impact and what areas does it look like we're having some problems. So it's a little early to say because this review paper hasn't yet been published. But I think if you were to ask me that question in mid-November, I'd have a better answer for you.
All right, thanks, Sherry. I think there's another question. I understand that AMGTA aims to promote the environmental benefits of additive manufacturing to key industries and the general public. What are the challenges that you have faced when you pushed out initiatives through an AMGTA's point of view? And what are the steps and efforts that you took to ensure that the community is receptive towards what you are doing as an association? Sherry.
Well, I think in terms of business development and our membership recruitment, despite the COVID pandemic, which has certainly been a challenge for a lot of companies, we have different membership levels, and we were thinking that the founding membership level would be full certainly by summertime, which is a long-term commitment. It's a sustaining member commitment, and there's a board seat involved. And actually, that has not happened. We haven't fully filled those seats, but companies are instead coming in at a lower level, a participating membership level. So we do have several founding member companies that we'll announce tomorrow, and we do have a total of 12 companies from 8 different countries that have come on board who identify with our mission, that want to help us with the commissioning of more research so that we can really get an understanding of where we are in the industry in terms of sustainability and where we need to go. So I think the fact that we've gotten the traction that we have and the momentum coming into October here is a very positive indication that companies identify with our mission and want to be part of our organization.
That's amazing. That you've gathered, in such a short space of time, a global community to come together with your main focus in sustainability. Just one question to Karsten before I hand you back to Nora. What will be Siemens' focus in the additive manufacturing space within the next 1 to 2 years? With the launch of AMTC in Singapore, is Siemens placing more focus in Southeast Asia as compared to the rest of the countries? That's your question for you, Karsten.
Yeah, thank you for this question. And I think many of you in the Asian area may have attended our opening some weeks ago. We started some years back in our German location to build the first hub for an experience center. And now we are bringing this into the different regions. And as I mentioned in my talk, Benjamin Moy is heading this. And this is the whole purpose. We need to educate people. We need to train people. Engineers are not used to design for additive. So it's not just talking about it. It's not just selling software or products or hardware. It's educating our engineers. It's working with the universities to get training in place. It's about developing and transforming the industry. And this is a massive disruption. And therefore, I think the AMTC Center, the Advanced Manufacturing Transformation Center, is one puzzle piece of that. We teamed up with a lot of partners from the different machine builder side. We have as well memberships coming up there. And we have very, very nice projects starting in the first phase there on different local projects in Singapore. I think this is a great ability to team up. And besides that, Cheryl mentioned Formnext. And I wouldn't, being the advisory board member in the Formnext Beirat, I would like to invite everybody as well into joining for the digital Formnext. We need to team up. We need to partner with each other. And it's not about competition. It's about working together to make this happen. And there, the AMTC is a big step for Siemens. We have a great focus here in the middle, in the Asian region. And we're working with customers from Australia, from Singapore, from all the areas. Already, just one example, it's concrete printing. Printing houses with robotics and additive manufacturing, it's incredible. It's amazing what you can do in this area, but you need to transform a complete building industry. They are not used to use software. They are not used to take robots for printing concrete. So I think we need to work together. We need to educate and train engineers, and we need to get new students motivated to work in this field to make it happen in a broader scope in the next years.
Absolutely, Karsten, I totally agree with you. It's all about capability development and getting everybody on board to get a lot more adoption in this space. So, and I know a nice conversation is ongoing there amongst the panelists. So Nora, over to you to take it over and ask a few other questions from the audience as well. Nora?
Sure. So I have a question here from the audience, specifically for you, Blake. Someone would like to hear more about the nTopology platform. And actually, the question is also about if there is some sort of enterprise or startup rate that is given to companies who are interested in exploring the platform but have budget limitations. So I don't know if you want to speak to that.
Sure, certainly. So, nTop platform is very much an advanced engineering tool for design for additive, design for advanced manufacturing. And I think, our website does a great job of explaining sort of the industries that we work in, as well as the applications. And that's a whole long discussion. When it comes to, startups, small business, education, we always work that out on a case-by-case basis. We have a few programs in place for that. Similar to what Karsten said earlier, we recognize that it's not just about selling a product here in the Asia-Pacific region. It's about training a workforce. It's about teaching engineers who have been in the industry for a long time about what is designed for additive. So we're very supportive of growing nTopology users within education, within research, at all different levels, not just the enterprise. So please feel free to reach out to us, whether it's through the website, my email, and we can have that conversation anytime.
And actually, I have a follow-up question to all of you about education. I think we definitely have all a role to play in making sure that the next generation understands, what's at stake. And I think some of them do actually, and how our technology and how additive manufacturing can help. Like, do you have any tips for anyone in the education sector or younger folks who might be listening to us right now?
I'd love to comment on that, if I may. Oh, go ahead, Blake. That's fine.
Yeah, if I may just continue, just take the picture from the CNC world. I think very going back in industrialization with CNC technology, why do we have this level of educated people? Because the whole community started massively to move into training courses. And I think this needs to happen here once more. We need to train these people using the software. We need to train these people using the machines. We need to train as well our maintenance staff and health people in our factories how to deal with additive. This is a totally different story. You need to look on health and safety people, how to train them. You need to look on the factory manager, how to train a factory manager to run an additive factory in the future. So you have a lot of different levels, from the blue collar to the engineers, to the software designers, to the factory managers, till our CEOs, where we need to work with them, how to focus on the topic, how to put the right strategy in place. So I think the training and the education goes through all levels of our different people, and there we need to work a lot together with institutes like NAMIC and others. I think these associations are doing a great job in getting this bundled in ecosystems to team up and then to train and engineer or make the engineering happen.
Thank you. Sherry, you want to go next?
Yeah. I think we need to start younger, middle school all the way through high school, as well as, of course, you could certainly make the argument that college-age young people could also be attracted to this industry. But I think we have a big challenge with perception of the word manufacturing has a negative connotation. People don't understand the clean environment, the use of software, and the higher level of skills that are needed versus what one would think of in terms of traditional manufacturing. In terms of the computer usage, I don't know that it's common understanding that so much technology is used in this industry. For the lay person out there, the parent that has a young person that maybe isn't college bound and is looking at apprenticeships and that type of training, this is a great industry for someone young to come into and to do a work experience program and then come back as an intern and then maybe get a job after they graduate high school or after they graduate college, or in between, maybe a 2-year study program in college. So there's a lot of places where people can fit, young people can fit in the industry. And I think getting a way to reach those young people is really key. And there's some really interesting companies that are doing that. One is called Edge Factor out of Canada, and they produce these high-end videos that educate not only students, but parents, as well as members of the community, economic development people, and also the companies themselves can get involved and have videos available for people to look at that are interested in perhaps working for those different positions that they have open and coming in on the ground floor of a great opportunity.
Thank you, Sherry. And this is perfect way to actually end our panel, talking about the future and looking ahead. So Mahendran, I think I will hand it back over to you.
Time has flown by so quickly with so much great content delivered today. Thank you, speakers and the moderators, for 2 wonderful sessions. I hope everyone had a great time with us today. Today's session is certainly an exciting one, and we've heard how we can utilize AM to ensure sustainability in metal production, fashion and food industries, and even sustainability in the AM industry itself. I'm sure you're eager to learn more about the exciting developments in AM. We'll be back tomorrow with another day focusing on emerging applications, where our stellar lineup of speakers will be sharing with you on new and upcoming AM technologies and applications. It definitely is going to be something not to miss out on. So do log back in at 12 noon Singapore time tomorrow. Please also take your time to explore what is in store at the ITAB platform for more on Industry 4.0. We look forward to seeing you tomorrow then. Bye for now.